The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. My name is Nathan, otherwise known as Old Man Builds. Guys, what's going on, man? Gonna have ourselves a good show today. I've been building some stuff and it's coming out really good. So let's take a look real quick. This right here is, sorry, let me grab it. This is Ian's Cat Bank, and just turn it around the right way. You can see got a ton of different capacitors on it, and you could switch in between every single one. He says he got the design from Master Evo, so shout out Master Evo. Here's what I did. I went ahead and I made it smaller. Now this is what I usually use on my Tesla coil right here in order to get it to resonate in the right frequency. The 10s, the 22s, the 47s. It's usually just this whole top rail right here is what I use. So I did this. I got this going here. As you can see from the picture in the video, I went ahead and I did some other stuff too. So it's not quite 100% yet. But right here, you have our ZVS, and I got to hook it together. I haven't found a good way I want to do it yet. But you're going to get fans in there, heat sinks, and it's going to come out real good. You're going to be able to cool this thing down. We'll put a little plate on it right here, so we can cover that with a little Old Man Builds plate right there. And then we'll lay it out on the board. So this is the board it goes on. As you can see, we got the impressions in there, and then each one fits inside each of them. And then we'll put bolts on there to connect them down. This way, guys, when we go to run our ZVSs, we're going to be able to put it together and make a very complete unit here. So I think it's going to come out beautiful. So far, so good. As you saw from the pictures, that they look really nice. And then I've done a good job soldering them. Let's see if we pop this out real quick. I have 4 of these made so far. You can kind of see that right there, the bottom. Yeah, I soldered it up real clean. But what it does is it allows you to turn on each one of the capacitors individually. So as you hit the switch on each one of them, it turns on the capacitor and you can turn it off. It always requires a little bit of cooling on the ZVS itself when you do that, because it'll tend to get hot on you because you're flipping in between the correct capacitance and not. So it'll go ease of flow to a ton of resistance. So you kind of have to watch it a little bit on the temperature right there, or else you're going to lose a MOSFET or two. So what's going on, guys? Oh, man. What's going on, Joe? What's up, Jarvis? What's going on, man? Yeah, we got a lot of stuff, man, on this thing right here. Right on. Thank you, man. One of the things I like to do, guys, is turn on my Tesla coils. You guys have all seen it. I resonate them and just put a number 2 coil out there, and I'll take my primary and run with it and turn it on and get resonance at a distance. I think a lot of people do not understand the mystery behind resonance. And it's not really a mystery what it is. It's more of It's a frequency. You know what I mean? They're antennas. It's basically what they are. And you're sending out not only the frequency to it, but you're sending out power. I think that's the biggest misconception right there of what you're doing. So you're sending out power, but the power comes in and then you can use that power. It all depends on how you ground it and cap it out. So if you know what you're doing, it's not hard to capture the energy. It's just like a Bedini device. At that point, you got a high frequency, you need to put it into a low frequency, so it gives you some amps. So there's a conversion there. That's kind of why I'm showing the conversion on my channel, so you can take a look at it. There's simple conversions and then there's big conversions. So I could sit there and take a transistor and saturate it and turn it on all day long. That's not hard. You just take the base, you know what I mean, and take the drain and the source, and then, amplify the base, and then the drain and the source go right on through, and the energy flows, and I can get a consistent on and off frequency to it. I don't need to fully rectify everything. What does that mean? That basically I could turn on one Tesla coil, and I could probably put 20 of them connected to it. That's pretty good. I mean, who knows if that's over Unity or not? They keep changing the goalpost on us, so I don't know which way is which. But to be very honest with you, man, 20 Tesla coils for the price of turning on one sounds pretty good to me. So it's a little trick. And I know that it's because I'm taking advantage of the actual way the energy builds out. But one of the reasons I want to tell you about this, that capacitor bank, man, it puts you right in line with everything. So if you don't have the right frequency in your original coil, you just hit a couple buttons on the capacitor bank and it turns on that number 2 coil at a distance. That's it. You put the correct frequency in, you get one at a distance. Now, Bernie and I had a chance to talk with Sheila about this, and then the cool thing is she's showing you in 3D on an oscilloscope how it builds out. So she's building flowers out of it, but it also matches how resonance goes in a room. If you go into a theater or a church or something like that, and you get resonance going on there when people sing, what you're going to find is there's zones where energy goes. You know what I mean? In the room itself. It's building out a field just like that in the room. That's the trip. That's what resonance does. So when you activate it in a system and you put it into a sphere shape, you're getting that look. That is the exact way it builds out in the pattern. So you got to have coherence. Okay, you can't have an incoherent pattern; it won't work. I just did a test here, and I just turned off my Tesla coil. It was on for 24 hours, and I put Epsom salt in there with some hot water and spun it up. Right, it's supposed to, a couple hours, 3 hours, something like that. See at least tiny little crystallization on it, guys. I got nothing. It's been 24 hours. I don't even have a crystal forming in the bottom as salt. Nothing. This thing, it completely blocked the frequency of the crystals themselves. Now, is it 100% conclusive? No. I got to run like 4 or 5 more tests on it to find out that's the case. Running it 24 hours is one thing. Running it 3 days, maybe maybe then I'll get a result. But it goes to what I thought about the crystal, is that it actually takes the correct frequency from the crystal itself with the energy it's putting into the water to rebuild it, to add more crystal to it. Now, like I said, not 100% conclusive, but it's a start. So the next test is going to be put the rod down the center, put it in the water, and then turn on the Tesla coil for 48 hours. Let's find out what it does. First, we get it the final control. This one's got to sit for 24 hours without anything and see if anything forms in it. Then we start a new one where I put the rod down the center, put it in the water, and we see if that one forms crystals in it. And then we'll do a separate control test where we just put it in normally, keep it out of this whole room, and see if that one forms crystals. So it's kind of hit and miss on how we're doing it. We're just checking it out. We're not, super scientific about it, but we keep the same measurement amount, same equal parts of water to the Epsom salt. So, if we're right about this, it means a lot for formation of crystal. Because it does it in water and we don't have to use anything else, if the frequency in the water is matching the crystal structure, that means it makes it so much easier to put this down in nano layers. Now we can start coding things with it. We can start making it go to our frequency, our shapes, everything else. Once it heats, cools down, all it's got to do is dry out. That means that we can start putting in cheats and stuff, man. It's going to be a much different world if that's correct. Then we can learn all the frequencies for every single crystal. Then we can see which ones are coherent to each other. Just like Sheila did, she said certain frequencies work with other frequencies as combination lock in order to build out the pattern, right? So if we do this in crystal and we're able to build out a pattern in crystal, then we got this. We can build out anything we want. We can make super crystals. We could put an oscillator on one side and an oscillator on the bottom, and then in the middle make a power crystal. Then all we got to do is resonate it between the two oscillators, and we have a totally different structure for a crystal that works in a unique way to give us a resonance frequency. That's awesome. Anyway, that was kind of where I was going, man. Like I said, I built these capacitor banks so we can mess with the Tesla coil. Guys, if you're interested in those, just hit me up on my email. I haven't set a price yet. I got to see what the costs were and everything, man. I've been, you know what I mean, tearing my hair out, what little of it I have left, just trying to get these little things to be soldered in there. So those will be available. The Tesla coil right over my shoulder, I have those available if you guys want them. T-shirts are available if you guys want them. That's my plug for the day. So yeah, those VVSs will be ready here in the next week. So if you guys next week want to hit me up, man, and you guys get all of it at once, we'll put a price on it. So you guys should go out there and start flipping these switches, man, and getting everything in resonance and beat my numbers and my distances of them. That'd be cool. So yeah, we're doing that. But that crystal thing, I'm sorry, I'm going back and forth. That crystal thing, man's got me. Because I know it has to do something with the atomic structure of this crystal. And when you think about it, what's the atomic mass? What are we looking at? What are the numbers? How do we get that to work together? And I think there's I don't want to say this. It's a simple understanding of the musical scale along with the Russell scale in the atomic, in the periodic table in order to understand the atomic structure of it. And once we have that, then we could put it in and start creating layers. We already know that we can come over here and take graphene and put it on there and make everything super fast. We know that we could take the understanding of a transistor and make it into the outside shell of a craft. We just have to follow the rules of it. You know, one of the things we want to start using is something that's much harder to destroy, and you want to get into crystal. Now, they still use crystal in everything we do today, but I want to get away from the copper aspect of it. So if we replace copper with graphene in a transistor or in a shell of a craft, we have something better off. If we put that in layers on a counter mesh, now we have something really special. And that's going to go into a little bit of, what is that, DARPA or something like that, whatever that agency is from the U.S. government, one of their patents on how to do stuff on the outside of a craft in order to reduce the amount of energy putting pressure on it when you get into Mach. But it's really worth trying. We have to, learn how each one of these things work, and we need that stuff to be really fast. And the only thing faster than crystal right now is the graphene. So we have to do it. Anyway, we're getting close, guys. If we can prove out this thing on the crystals and, work with the one salt, get on to a second salt, then we can start working with some other crystal that puts off energy in water, and we can pull the frequency. I mean, like, if there's any amount of energy in the water when you put in a crystal, just understand this, it has a frequency. That frequency being replicated could build out that crystal. We could sit there with a microwave and put in the magnetron that exact same frequency repeating again and again and again and again, hit it with microwaves, and then get that thing to grow out. Now, depending on where we go with the frequency, and it lets us on the outskirts of the direct frequency, just on the outsides of it, we could be able to put this thing into super rock hard form or super malleable form. It all depends on how you do it. So we have a big insight if we just learn how these crystals work and how we can manipulate them. They're already doing it with diamonds. They already did it with quartz. The people who do this stuff for a living are way ahead of us. It doesn't mean that we can't learn. So that's kind of one of the structures we're looking at there, and I think it's going to be awesome. Yeah, we got to dial it in. That's 100% sure. Joe and I were talking about it quite a bit this morning. So, yeah, we got a direction to go in there. Don't you hate it when you're waiting on supplies? I always hate it. I hate it when I don't have enough money that week and I got to wait till the next week. That one really drives me nuts. Do you have seen any graphene 3D printing filament out there? No, I have not. Nice. We should be looking at the plasma unification model for this insight. You're right. We should. Right on, brother. Nice to have you. Yeah, there's a lot there. And yes, it all coincides. So what I tried to, I sent Joe this, and I sent this to Bernie, and I don't think they quite got it. What I was simply showing is we have a very vague understanding of a very big problem that's happened over a lot of time. Alchemy is no different than when you get into harmonics. Harmonics is not much different whatsoever in resonance. It's all part of the same structure. What I sent to them was something that was written in alchemy, but put on a musical scale. And it's important to understand why. If you put those symbols on a musical scale and they're right, what is that telling you about the element that you're creating? See, they cross elements when you put in certain two salts, right? Two salts will change the structure of that crystal to do something else with the crystal, right? But what if alchemy was no different? What if it just took the frequencies of the item that they're resonating at on the Russell scale, and then we put it in with those light frequencies that have a half, quarter, eighth wave, whatever it is, in there with them? Can they build structure that way? Is there something that we're not seeing in material science that actually builds out that way? You see, I think it's easier than people think it is. I think it's just about learning it. And then once you learn it, you can apply it. So when we have ormus, can we rebuild it into something else? Yeah. Yes, we can. That's the whole trick here. I said in the video I did on the members channel that they take diamonds, and we all know magma process, getting hardened using, what is it? Not graphene, but carbon in order to build a diamond, right? It's all about the pressure. It's all about the heat. Well, that's the process to break it down. Okay. And it reassembles based on resonance in the chamber that it's in. It needs a frequency. It needs a structure. And yeah, you're going to compress it. Yes, those things are absolutely true in order to get that, but that's why it's under compression. You have to put it in the frequency to give it a direction. So now if we understand that, can we do that in a different way? Now they also use, in order to harden crystals, they hit it under microwaves and it builds a structure smaller. Why is that? Well, it has something to do with the frequency and the distance of the frequency that it travels, okay? Frequency equals energy over distance. So when you do that, it's like frequency equals 1 over time, except for the thing is you're doing the distance is the time. So once you understand that, then it's pretty simple to understand. Where's the frequency going at? How many times are you repeating that every single time in a magnetron in order to hit that frequency, in order to grow that crystal harder? But it's more than that. They were looking for something very specific when they did it. They wanted the blue diamond, the one that when you put it under, what do they call it? I don't want to say magnifying glass. I want to say heat. When you look at it with the heat camera, the infrared. When you look at it under infrared, what happens is you see it glowing a little bit. There's energy being built inside there at all times. They're building these diamonds in order to get that energy in there at all times, which means they're self-oscillating. That's an important discovery right there. So now when they do that, you go, okay, they know how to do it based on that distance right there. So now that they do that, now we can make the perfect power source for anything that we want using crystal structure just like they're doing with that diamond. That's why it's very important to understand this stuff. Man, it's a whole new path to go down when we talk about this stuff. So I wanted to build a Tesla coil out of it. Seems pretty simple, right? For two frequencies on an oscillation, and then we put a little bit of power into it. Guys, I can run a Tesla coil on 3 volts. Give me a better transistor, and I can run that sucker on 1 volt. You can oscillate things at very low voltages. I don't think people really realize that. It's just not a whole lot picked up on your oscilloscope. You have to really dial it in to see it. So, yeah, I mean, it's all right there. So if we want to do the crystal form, we have to get into that. One thing I'd like is be able to make graphene a little bit cheaper so that we can put it on the outside and test it out. It's super fast, man. When it comes to electric conductivity, it's super fast. That's why we want it. We want that thing, man, to pump that energy out, man. We want that thing to really get cooking. And it's strong, too. That's the thing, man. It builds out strong, and it's fast in electricity. There's a lot to be said for it there. Now, we get into bismuth. That's one of the things that we get into when we get into transistors. It's very interesting because people always think it's the bismuth. They get caught up in the crystal structure and what it does. But it's actually the lead portion of it that interests me. And it's because the reactants to lead. Now, lead can become a superconductor, but it has to have the right conditions. You can also make mercury a conductor because it's liquid. But what if we wanted to take a little bit of the best of both worlds and take the bismuth and make it liquid at some times, but other times we want it to be lead? We're up in the air in the craft, we want it to be liquid. We're on the ground, we want it to be lead. We want it as an insulator. We get up in the air, we want to use it as a transistor so that we can get the energy and amplify it right away and get to the other side of it. I know a lot of people just think, what are you talking about? Transistors, you want a capacitor. You think you got them wrong. No, I don't. And the reason is this, is the transistor is a small amplifier. The capacitor is a large amplifier. They're not much different. We're just dealing with layers that simply saturate one to the next. In both products, that's all we're doing, is we're reaching a saturation layer between them in order to turn them on and off. That's it, man. One holds energy into it a little longer because the layers are bigger and can have the capacitance level. The other one's meant to turn off and on real fast. That's it, man. They now take capacitors and stack them on top of transistors in order to make the next generation of computer parts. Also, they're in the DRAM, I believe it is, in your computer. Back when that was a thing, I guess. But what I'm saying to you guys is they've already figured it out. The material science is already done. We need to apply it to what we need to do. So outside of crafts, UFOs, why do we need to look at it? It has a lot of more properties than you think it does. And let me just say this. I learned this about energy. When you get into a field that's a high static like the atmosphere, right? The only way to cut through it is do the same thing the Tesla turbine did. Tesla turbine, the only reason it doesn't work is it went too fast into Mach. It pulled it into Mach. Just understand that. It didn't go into Mach like hitting a wall. It sucked it in. Okay? There was a big difference. It was going too fast. It would make it go too fast. Now, what's the understanding of that? Well, a Tesla turbine blade's not much different than a UFO, but it's the energy level that it puts out on top of the plate. It's the charge state that it gets into. That's exactly what they used in their bombers out there in order to make that charge state less so they can get more fuel economy out of this thing and that they can, go through Mach faster. That's a big understanding here when we get to UFO crafts. You have to understand how it translates to what you're doing. Now, do we want to spin a craft super fast? Yeah, maybe we were in the 50s or something. It might have been cool. Nowadays, we don't want that at all. We want it in solid state. So what do we want? We want the outside layer to be a nano coating. We want that graphene on the outside, so it's super fast electricity going around that craft at all times. It basically makes the craft feel like the environment around it. It doesn't notice it's there. That's the point. You see, you get resistance in there because you're building up an energy in a wall. What if you dissipate that energy? Is that wall still the same? I don't know that it is. That's the thing. That's what a lot of people don't really look at is the outside wall of everything, man. It may go away. Once you hit that energy level you need to, it may go away. So I did another thing, and I put it out there on my gravity flyer for those of you who are interested in the project. I was playing with the energy in it. And, I don't want to say flipping fields. People get all messed up in the head about that. But I changed some energy in there, and I don't think people caught it. I was creating a capacitor between two coils. I take a number 2 coil, and I take a second number 2 coil, and I counterwind it and put it in the center of it. One has a magnetic value hooked to the negative of a DC flyback. One has a static value hooked to the positive of DC flyback, right? We have two different fields. When they are sitting together, they push on each other a little bit and create some capacitance. When they spark, you get a DC flyback spark, right? Not a problem there. Builds up nice, beautiful spark. You know what I mean? Nice, beautiful plasma. It comes out, has some white in it. Absolutely gorgeous, okay? The way it should be. What happens when I turn on the Tesla coil field? You see, the Tesla coil field is AC, is what they said. It's a sine wave, right? Well, is that the same thing going on in your DC flyback? Well, on one side of your DC flyback, it's a square wave because you have the negative, which is a DC pulse wave. So that's going on there. The other side is a rectified DC going into an AC field. So the Tesla coil itself is pretty much a neutral field. It'll amplify both sides, the negative and the positive. Now, for those of you who haven't worked in waveform before, you could take two different waveforms, run them at the same time. You can run a DC pulse wave and run a sine wave right over top of it. Now we get into the understanding of what it's doing. As soon as you turn on the Tesla coil next to those two counter-wound coils, one inside the other, not touching each other, not attached in any way. They're hooked to that DC flyback. You turn on the Tesla coil, what do you get? The capacitance changes in a very specific way. We saw the spark come out. Nice, beautiful, big spark, right? Now it's a very short, controlled burst. Okay? Where do we see that? We see that in taser modules. We see that short, controlled burst. We see it in a AC flyback when it has a voltage multiplier on it. So what did I do to the field? Well, in part of it, we still had our, DC square wave. In part of it, we had a sine wave. In the Tesla coil, it had a neutral field, but the neutral field was actually, comes out in a sine wave on your oscilloscope. I have a very distinct feeling that energy in there was AC. And why does that make a lot of sense? Well, we talk about UFOs. People talk about the three-phase AC power that's supposed to be able to make those things lift. What if we were creating something like that and we didn't really realize what we were doing? So we changed that energy. And by adding that Tesla coil field, see, we add more energy when that field comes in. It makes the capacitor better. When I started to move the wire up and down, right? We get that thing going. What happened? You see the capacitance built in the field. You say, well, why would that be? That doesn't make sense. Please remember how physics works on this. You take two plates, you put them together or close together with a little bit of distance in between them. You pull them apart and it rapidly expands the field, pulling in energy. You go from 9 volts to 1,000 volts. Well, what happens when I start out with 40,000 volts or 60,000 volts? And I pull that apart and I put the Tesla coil field in there to amplify it. Well, that's exactly what's going on here. I am now pumping out a much, much larger field continuously. Now, it takes a couple of times to get it to go before it hits a real field. That's kind of the point here, though. You see, you hit it once, field builds out a little bit. Hit again, field builds out a lot more. A little more. A little more. All you have to do is contain the capacitance now. Well, Tesla coil's got that covered. You see, for as much capacitance as I created, it wouldn't go in anywhere in my garage. It stayed right there because I put the Tesla coil field on. It was able to contain it. That's kind of the trick here, though, isn't it? You have to know which side of what to put where in order to contain these things. Just had to run a little coil around the outside and put the Tesla coil field from the inside into it. It's a different energy because you are making an impulse out of that instead of a regular pulse wave. Regular pulse wave is outside the Tesla coil. Inside the Tesla coil is an impulse. It changes the field that goes around the whole thing. You see, you can't describe the state of energy and everything that goes on without the whole field itself. Because you can change in between AC and DC at will if you know what you're doing. That's kind of why I'm showing the videos as well where I convert things. Because I know what I'm doing. I know I'm switching from this one to that one. I'm able to get this different type of energy that goes on in there. You know, not a lot of people sit there and mess with these two systems in the way that I do. And it's because I've been around them so long, I've kind of figured out what they're going to do together. When I told you I'm going to take them and put them on the bottom of my gravity flyer in that little bar, and that the Tesla coil frequency is going to take over for the DC flyback frequency, I was 100% correct. It did it right away. And it put a resonance between the two. We had a resonance between our DC flyback and our Tesla coil. I also got a resonance between my two motors. And in between all those, I got a beat frequency. Wild, huh? Well, one of the cool things is about a Tesla coil inside of a Tesla coil, if you change the inside PVC pipe to something else, you can start to develop a resonance inside each pipe. That's interesting. Not a lot of people realize that. You take a pipe a certain length, you take another pipe a certain length, and you can move one up and down and create the resonance inside of it. But you can also take a toaster module and take out the little part that heats up, put it right in the side of a crystal pipe, and then what happens? It starts to create resonance in that pipe. Put another one of a shorter value right next to it. What happens? They both resonate each pipe, but then they create a beat frequency in between the two. That just has to do with the pipes you're doing. It's how the via mana is working. That's how they're doing it. They got two pipes that are the same size and then two more different size, and then they create a resonance and a beat frequency between it. There's a lot here, man. A lot here to unpack. It's going to say that too. Nice. Anyway, it's all about resonance when we talk about UFOs. For those who don't say that and don't understand it, they won't get it. I mean, I look at resonance like I look at quantum entanglement. If I can start a Tesla coil just by frequency alone, I mean, think how ridiculous this is. I wind a number 2 coil to a certain frequency, right? I put absolutely zero power into it. I put it across the room. There is no way that that thing should start up in God's green earth, right? Not a chance. There's no power to it. There's nothing. But then I turn on the Tesla coil from across the room, and based on that frequency, it turns on. You see, it's entangled to one another by frequency alone. It's now resonating with the same frequency that mine's resonating at. That's the only way that we get energy from one thing to the next. It's a misunderstanding in space, man. There's just nothing there. In between planets, there's nothing there, man. In between everything else, there's nothing there. What happens is you create frequency at a distance and it entangles things. You can then have the energy match the sun. The sun carries all the frequencies that go on in our solar system. Every one of our planets attached to it. We are in direct relationship with that sun. That's how they do it. It creates patterns, it creates shapes, it creates things like that. I don't think in any way that it can be undone that way. It's the only thing that can do it. You see, in order to understand that, you have to understand scalar in Tesla coils, not in physics, just in Tesla coils, on how they transmit their energy. And then you'll start to get the understanding of what's going on. They do it at a distance. I don't even need the ground wire, guys. That's what I'm trying to tell you. I do not need a ground wire. I just don't. If I want to amplify it, I can put it in there. If I don't, I don't have to have it. If I put it into the ground to amplify, I'm pumping energy out of the ground. I don't know if people really realize that. You're directly pumping energy out of the ground. You can just hook that thing to a spool of wire for your ground. You know what I mean? It'll pull energy right out of there. Sean uses some big brass balls, you know what I mean, in order to pull some energy out of those suckers and put it in his Tesla coil. The energy comes from it, man, from that grounding thing, because it's a pump. The Tesla coil has always been a pump. But once you understand what the pump is doing, then you have it. It's a lot of energy everywhere, man. We just don't realize it. You can't tap into it. That's why. I find it hilarious. People go, we're in a 0-point field in the earth, right? Okay, I'm there with you. You go outside and you say, okay, there's energy everywhere. And they go, I don't see any energy everywhere. But I thought we were in a 0-point field. Well, I don't see energy everywhere. Well, hold on. We're in a 0-point field, right? The Earth is creating 0-point fields at some point, right? We're creating this big ball of energy, right? Big balls of energy. We see it in this, beautiful thing on the top, a beautiful ball on the bottom. We see it in this beautiful ball on the outside. There's energy everywhere, right? Yeah, there is. Well, what about when you walk outside? They go, nope, not having it. We don't live in a sea of energy. Are you sure? Like, do you just think that you're not able to get to it? Kind of the misunderstanding of life, isn't it? We create Earth batteries, for God's sake. We get the voltage right out of the sky to run on corona motors. We go down the hallways in our socks and rub them together, create friction, and we shock people. It shows up everywhere where the energy is. You just need to know how to get it out of it. You see, you're creating friction going down the hallway in your sock, creating friction in a field that allows for static to implement itself, gives you the ability to have a static charge, right? I'm not saying anything different than science is telling you. Go take a PVC pipe, take a rag, start getting that rag off on it, man, and you're gonna create some charges on that sucker. You're gonna be able to, move the aluminum can with it all day long. You know what I mean? It's not that hard to understand, but you're not creating or destroying energy. You're just taking it from the environment. So therefore, there's energy in the background everywhere. Do you know how to pull it out? You see, that's kind of the thing. You have to make sure you reconcile everything that you're saying. If you're in a 0-point field, that means there's energy everywhere. That means that you need to learn how to pull it out. It shows up everywhere. You need to learn why it's showing up there. Charge states, energy, electricity. We're getting static electricity. These things aren't miracles. They're just simple science on how you're pulling them out because you didn't create them. You created the environment for them to come in there and adhere their charge to what you're doing. You didn't create a generator. You created something that allowed the environment to pull into that generator and give you the charge. That's what you did. Therefore, when you say a Tesla coil is a capacitance to ground, and I tell you, I'm taking this whole system right here of this UFO thing and I'm grounding it in a bottom with magnets, and that's my negative field. I got a magnetic negative field that's in there, right? And that's my floating ground. Okay, now I have the top of my craft is a capacitor between two plates, the center and the top plate, to ground, which is right under it, right? I now have a capacitor to ground. That is what the Tesla coil is doing. All I have to do is flip the charge on that center plate. That's it. We get the understanding of a lifter that's much different than what most people think it is. Ion lifters are a freaking joke. Okay? There's somebody who didn't know how to build the real thing. When you flip the field, again, I'm saying it, sorry. when you're changing the energy from the top to the bottom, right? So this part is negative on the bottom, positive on the top. You want to bring the negative to the top of the plate. You're changing a charge state, technically, okay? That's all you're doing, changing the charge state and putting it on the other side. What does that make it do? Well, charge state's going to attract to the positive, right? That's not hard. We learned that in magnets, okay? We're going to attract to it. Well, what's the problem? Well, it's got to take all the energy in that negative part to that positive part. That means the entire mass of the craft has to come up to meet it. That's why these lifters carry weight, where normal ion lifters don't. It's already creating the environment. I don't know how to even put it to people, man. It's all pretty much been done. We're just not putting it together in the correct form. Like, we're not seeing how they're interacting. We're not seeing that the fact that they are the same thing in certain instances, and they're not even close in some instances that you talk about in physics don't exist because they're part of a different structure. It's much different than what people think it is, man. Yeah, T.T. Brown did it as well. I 100% agree with you. T.T. Brown, I don't know if many people really understand this. The dude's creating electrons. I mean, think about it. High K values, right? He's creating a transistor and a capacitor combo, okay? A stacked one inside that as an electron. He has a permanent charge state in there. And he uses high voltage to do it. It's been done a long time ago, man. He gets a very high K value. The K value is how much you bake into the cookie, man. You bake it in there. You have that amount set already. Now, can you keep everything aligned to keep the charge state? Can you keep it flowing around the outside? Well, see, that's the brilliance of it, isn't it? That's not really that hard to figure out if you know what you're looking for. If you knew all you had to do was line it up, okay, you go, okay, tunnel vision right here. Putting in an aluminum keeps the charge state aligned. When you take it out of the charge state, okay, it misaligns. And then you lose charge. Well, what do you got to do? You put it back in the aluminum can and charge again, right? That's why I tell you about the mesh. The mesh gives you both best of both worlds. It gives you the charge state along with the open state, right? Why do you think I like graphene so much? It's an open state and a charge state at the same time, but it's extremely fast in the amount of energy you could pass through it. Now think about that. I have 2 to 3 to 4 times the amount of energy passing through it at one given time because I have the correct material on the outside, but I have an open and a closed system in the same one. Now I'm in a complete charge state at all times, but I have an open air thing, so I can get the value out of it in open air. That's T.T. Brown all day long. That's what he did. The rest of it was a Tesla coil, man. He got that outer field out of that coil, man. He found the same center right down the center as we did. Yeah. Yeah, it's definitely not cheap, though. I agree with you, Jarvis. It's not cheap, but it's the right way to go. And the trick is, can you make the aluminum work at a very cheap, what is it, $8 a roll? I mean, that's fairly cheap. Aluminum has the same value as your aluminum foil. You just, you know what I mean? It runs at the same speed. They used to use aluminum. They went to copper. Copper holds in energy too much, so it heats up and dissipates. So you don't want that. Aluminum has an eddy current to it, so it moves a little faster. Look at other materials. Silver would be even better. It has a really fast amount of charging in electricity, and it doesn't retain a lot of heat. It's one of the best conductors out there. You can use that. But in a, what do they call it? Is that a metamaterial or whatever it is that they call it? Graphene isn't, and I'm not sure. Whatever they call that, that's the material you want because of the high amount of speed and energy it goes. Flash graphene with a Tesla coil. Well, Tesla coils are a little different. See, you don't always have to have a Tesla coil thing. You have to have the Tesla coil effect. You have to be able to create resonance inside of something, but you don't necessarily have to have a Tesla coil. That's the beauty of it. See, that's where you go from one thinking state to the next. You go, okay, I want a different device, but I want to resonate it. Well, bring in your rodent coil. We can resonate 2 of those wires, man, no problem. I'll take a cap bank and put it on each side, and I'll balance out the capacitance between everything in your system. I'll take out the heat because I'm going to run it really fast in electricity. I'm going to use a battery, not the fire hose that's a wall. And I'm going to go ahead and I'm going to pull that electricity right through the entire coil, which happens to be the best way to cool that entire thing down. Now, I do not have a core in it, so I do not have to worry about the resonance frequency of the core. You just have to pull it through and get it to resonate. The colder it gets, the more energy you make. That's the way it works. That's the way the rodent coil works. But then again, the geometry coil is working on the same system. If you can get that thing to freeze over, you've done your job. You're creating that energy in there. You're pulling all the energy from the environment in there, I should say. Why? Because the environment pulls it out cold because we're in an electricity state. We're not under the ground. The ground right there is where you go into an amperage state. That's why they use it for batteries. We're still in the electric state. We're just on the negative side of it, which proves out when you get up to the upper atmosphere and you go, well, this is pure potential. It's in a negative electricity state, which means it's not AC at that point. It's a potential energy, which is the same thing we're in right now. It's just a lower level of it. Now we can pull that energy in. That's where the understanding is. But you have to get it colder. You don't put it in items to make it colder. It's not like put it in the freezer and you got your answer. Okay, it doesn't work that way. It's the environment. It's all of the air. It's all of the gases that are in the area. All of it that are pulling through this thing. Okay, it's making a charged state that's colder. Electricity is cold. Amperage is hot. Once you understand that, now you can understand what it's doing. You're not over here doing it what you do in a superconductor. We're not super chilling this stuff. That's not what we're doing. We're letting the environment make us the superconductor. We're allowing it to frost over and cold. If you've ever seen a meg that resonates properly, if they've ever taken the actual core of it and resonated the core of it, what's the core frequency? Not a lot of people even look at that. They go, who cares? The core. Well, you care because it's how fast that thing's going to oscillate, right? Anything that slows down the oscillation gives you heat. This is 101 when it comes to copper. The faster it flows, the less amount of heat it gets. As soon as you create heat in it, you're creating an amperage wall and you're going to slow it down. You're going to pop all your breakers. But that's the same thing in a meg. As soon as you create that, you create heat in that core and then you stop it from oscillating properly. But when you hit the resonance frequency of things, what happens? It goes much faster. It flows. It allows the electricity to pass through it without a problem. And of course, they get a cold value in their amperage, which is the magnet. It's already putting out the field. You're just shifting it. That's the meg. That's pretty interesting, man, the way it's working. But it doesn't mean you can't do it with other systems. You don't have to have a core in it. You just have to understand that that's what's going on in your copper. A lot of people understand that. They say, well, copper is what we use and we just use copper. Yeah, that's, it's the way it builds up and we got all these electrons that go on it. And they're not getting to the core issue. Are you heating the copper up? That's the big question. Are you heating it up? Nobody really looks at temperature. They look at it as, oh, my MOSFET got hot and I blew it up. Don't you think you should look at the temperature on the wire, man? See what's going on there to see if it's using your energy? That's hysteresis, man. It blows out the energy and heat. Energy isn't just going to be in your system because it's energy. You know what I mean? That's a misnomer in your head. That thing, man, as soon as you create heat, the energy's gone. You're going to start dissipating at a huge rate as soon as you heat it up even more. This This is why you want electricity in most of these systems, and you want cold amps if you can get them. You want that magnet in there, in that core. You want it to do the work for you without actually having to put a magnetic field in it that creates heat. It's brilliant. It's just brilliant. I mean, pull the electricity through this thing, just like you do on PMP. It's not like they didn't tell you how to do it. They did. They created a PMP circuit that basically pulls the energy through it. If you're pulling it to the coil first, then what happens? The coil gets the energy first and it's cold. You resonate that energy inside there in the cold. You're not building up heat. You're building up energy inside of it. You can move that heat on the outside, inside, anywhere you want, depending on how you connect this thing. That's the understanding here. We get a very, very nice amount of energy out of it. Oh, yeah. Check it out. Old Man Builds Graphene shirt. All right. There's my second plug for the day. Old school, man. Got to have the old school stuff. Right on. Thanks, guys. Right on, brother. Yeah, so people wonder why I get into all these different systems and stuff like that. Normally, I don't do them, man, because other people are doing the projects. You know what I mean? I tend to try to stay out of the business. But when it comes in the middle of what I'm doing, I have to do it. And that's going to be the case with the geometry coil. Now, I got about 30 of these things, and I haven't shown any of them, man. I think I showed 2. So I'll take that back. I showed 2. I showed my Christmas one, and I showed my other one where I was building for, what was it? A hexagon shape. And it's going to be start time for those things to roll out. And you'll see some testing on them and stuff like that. I had to go down and wire them and learn how to do it and go from the bottom up. It was not an easy task. But I did the same thing with the rodent coil. I have plenty of videos that I haven't shown yet where I'm taking the system, I'm putting each side in resonance. Okay. Most people don't understand that. They think, man, I just throw a couple of caps on the first part, or I just throw the transistor in there and I run it at the frequency it's supposed to be in. No. You have to check the frequency in each coil that you do and see what it is. Okay, there's a certain way it likes to operate without bringing up heat. Once you find that, now you can use your ability to change the frequency in your system because you know, hey, this may be in a square wave, but I can run a sine wave right over top of it. You see, musical Tesla coils do that all the time. They put it right there in when they put the power in. See, you get lost in where the power is being converted in the Tesla coil. In the beginning, you start out with the DC, you can convert it to the AC. Just put it in the music. That's it. One over top the other. Not really, that difficult unless you get to the higher frequencies when you're trying to get into the megahertz frequencies. You got to use crystal oscillators, and your crystal oscillator circuit gives you a big pain in the you-know-what. Anyway, there are ways to do it, guys. There are definite ways to do this. So we'll be showing a lot of those videos here, man. For those of you guys who are members on the channel, I put up, Sean shared a lot of stuff on electrics. And let me make this very clear distinction here. Anything that Sean shows on the channel on the live, I put it up in the members area, okay, on his little videos that he makes. If it is not on the actual live video, it will not show up in there, okay? No extra stuff like that. That's between Jarvis and Sean. That's not between me and anyone else. Sean allows me to put it on there on the members section so that everybody who watches the electric stuff can get a look at it who's a member. It's just stuff that was showed on a previous live video in his little short clips. That's it. Just want to make that distinction out there because I don't give away trade secrets. Okay, that's not what I do. Anyway, I just want to tell you that I uploaded, I think it was 30 of them, and they're cool, man. Like some of the stuff, man, that he did, I'm still, I just want to replicate it because the electricity was cool. When he zapped all those plastic balls with that electricity, man, that he put in, let me see if I can't, I'll grab that one for you. Oh man, that was a good one. Yeah, he does some wild stuff on there, man. But I wanted to make sure I told you guys that because I don't want any kind of confusion of what's going on there. Okay, yeah, I found it. That's awesome, man. Yeah, you can see the flower of life in there, can't you? Look at it. You can only see it when it's running. Yeah, you can kind of see it right there starting to form out. It reminds me, and I'm not saying it's definitely what it is. I'm just saying it reminds me of what she was talking about when she says the frequency of the energy itself was putting out a pattern. We're now seeing a pattern in this, but it only goes as the frequency goes. When we're going from one side of it to the other, we're starting to see the pattern. So when you look at this, guys, see if you can't see that flower on the pattern. And think of what Sheila was telling us. There's a ratio that goes on in order to build the pattern out, right? And she was telling us there's leaves in the pattern in order to make it. So let's watch it again. I don't know about you, man, but I see the flower all day. Anyway, that's pretty cool, man. It's part of the cool stuff on there. So, like I said, for guys, I know a lot of you in the chat are members, man. Get on there and take a look at those. You get to see some of his other cool stuff on there, man. Let me I'll pull another one for you. Oh man. My favorites are when he zaps the balls, man. I gotta find the one where he does his brass balls in there. And he zaps the living daylights out of those things, man. Those are cool. So let's see. I think this is the oatmeal cookie that he was showing. They said it was one of his best ones, right? Yeah, you can't even see him in the screen. You see the meter going off. Look at that. Anyway, like I said, Sean shared a lot of those on the live. Everyone in there he's had on the live show. So there's nothing breaking him and Jarvis's work going on there, but it's really cool to look at. Kind of a look back, you know what I mean, at what he was doing. So you guys can kind of look at it for record and stuff. Man, those things are awesome. So yeah, basically, if you remember, man, they're all up on there. I think that's like I said, there was 34 of them or something like that. And there's a lot of pictures and stuff that'll go on the Patreon and stuff that he did. Again, none of it is stuff that they work on, the new stuff that they have to keep under wraps, but all the stuff they were able to share. So all that'll be there on that as well. So yeah. Thanks, guys. I thought it would be a cool, kind of a cool part to separate that stuff out so everybody has it on there, man. Yeah. The electrics, I don't even know how to read that one. If it's a bifather or not, Jarvis would tell you the answer on that. I just know the flow state. That's kind of what I was looking at. I know this. If you ever wanted a high voltage, high amperage, right? Not always easy to get. You're going to need some kind of magnetism underneath your electric. And you'll start getting a lot more energy out of it. The cool thing was, man, when they used to cover our transformers in beeswax. I mean, think of the implication of that. You're creating an electrically charged state into something that could retain the energy and has the alignment charges that'll line up, right? In the beeswax. If you do it right, okay, that's if you do it right, you can amplify this amount of energy. What are you running in that, in that transformer? Is it a higher voltage? Can you shake out and get a little bit more out of that based on that insulating value? Can you add more insulating value to it? See, I think they knew something in the past that we didn't know now. They were pulling a little more energy than we are. We get these generic things that don't do probably half of what they used to do old school. And that's one of the things that you find. You say, okay, well, they wrapped it in this cloth, but then what did they do? Well, they cover it in beeswax. Well, hold on. Now that we know that what the beeswax does, maybe we should look into this, right? Maybe we should start to check this out, huh? Maybe I might want to use that. That's kind of one of those material science things that you look into and you go, all right, hey, hold on, we got something here. Let's circle back to this. We're going to need to check that out again. I think that's a miss for us. You know what I mean? Yeah, I think that's a miss for us. Yeah, we got a lot of stuff going on, man. So, Jarvis, you want a link, buddy? If you're up to go, man. I mean, if you're up to go, I'll give you one. So, oh man, Jarvis says ceramics would be the next level. Yeah, it would be interesting, man. We think about it, man. All the stuff that I probably have an understanding of the coils and stuff that maybe we all needed to learn. I mean, we all need to see because maybe I'm seeing something in there that's helping me in this other thing to describe this. And maybe I didn't give you the proper link to it. You know what I mean? To understanding why I see it that way. So he said he didn't double dare me yet. Man, he's gonna come in hot. All right. Let's see. Let's see what he's got, man. All right. Let me find Jarvis in here. Why is it not? Oh, did you change your thing in my Facebook, Jarvis? I think you did. Yeah, he did. Jarvis, send me a message in Facebook, and I'll redrop the line to you. It's not you think you had VK or something instead of what you had before. This is not pulling up Jarvis. Pulling up a bunch of weird people. There it is. Sweet. There you go. All right. Here we go. Hey, real quick, I want to show you guys this. Oh man, let me see if I can't pull it up real quick. So this right here, guys, is my crystal experiment where I put the Epsom salt in there and I stirred it around. As you can see, there isn't a crystal in sight. Now, again, this is water in here, and it's a little bit over a cup of water, the same, you know what I mean? So half of that is salt and half of it's water, but I don't see a darn bit of salt in it, not even a slurry. So, and that Tesla coil's right in there, been in there for 24 hours. So it's not forming. It's not forming the crystal. So we'll find out, huh? I just thought I'd share that with you. I thought it was weird. I mean, think about it. Don't it should be starting something. Even regular salt puts a little bit on the bottom. You know what I mean? It's not doing anything. It's been clear for a whole 24 hours, completely clear. So, yeah, he doesn't like that Tesla coil frequency at all. I don't know what the deal is with that. So, we're going to find out. All right. Let's see. Is Jarvis coming on, man? You're probably getting set up. All right. You know what it's doing, huh? Go ahead, Joe. Oh, I had an NPN. It was a circuit that I had laying around. I was screwing with it, like I always do. So that's why I didn't have the PNP hook up to it. It was just something I had next to it, and I wanted to try it. I need a kiln now. Yeah, this thing popped on my screen. It's not ready yet. Oh, yeah, Joe gave me a very long description of it. And yeah, we'll have to wait until he gets on to tell you about that on Friday, because that's something that he's better off explaining to me, because I'll screw that one up. So, well, to be honest with you, man, what is the point of an electric? It's a pure electrical state. What's the point of a magnet? I mean, it's the same question. It's what you do with that state of energy. So rotate it. You'll see a magnetic state appear as you rotate it. Why is that? Well, it's because of what it's doing. You're creating both states of energy out of a pure electric state. Sean was saying it last week, man. Because I make sure I specifically asked him, because I have a rotating sphere that I need to get put an electrode on. I've been waiting for months. I need to put this thing on there. Once I do, then I can shoot the radiant energy right through it. Now we got something. Okay. I can't hook up wires to this thing. It won't allow me. So yeah, I need that electric. So, well, there's a point of it, I guess. When you do stuff like old man does and you go over here, you got to have that. So you see the rust? There's rust on there? I didn't see any rust. On the gator clip? Hold on. Well, see, I was looking for rust. I didn't see any. And I don't see the rust in the water. I had a gator clip in water and just regular water, and it rusted out real fast. Maybe on the bottom there. I'll have to look into that. You seen it on the bottom? Yeah, I think I see it a little bit. I don't know if that's shadow or not. What's up, Jarvis? Mic on? There
Yeah,
it is.
I had your YouTube in the background. I didn't
Oh,
want it to
turn it
echo.
on.
Hopefully, I don't have much lag.
No, it should be all right. All right. So, what do you think, man? What do you think that crystal's doing?
It was funny whenever I tried to first join. It said that I didn't have permission from my mic or my camera, and I tried, and I wrote this. Like I entered I was like,
I see it.
I'm sure nobody, would not give mic or camera. It glitches, man. But
all right, Jarvis, we're working on the actual Epsom salt. What do you got? What do you think it's doing? Because I did half parts Epsom salt, half part water. I put it in, mixed it up, stirred it real good. Okay, used really hot water when it started. Let it cool down in there, and I put the wire in there with my Tesla coil at 10 volts. Okay, on a Slayer exciter circuit.
well,
So
I think Epsom salt is a great start. You know, magnesium sulfate is really hydrophilic. So yeah, so even if you started with less water, you would get. Sorry, did I go out?
yeah, go ahead.
You would get more ionization.
Oh wow, you're lagging real bad. He said no rust was his point. Well, yeah, I didn't see any rust either.
I can't even tell if I'm on or not. I'm sorry.
No, you're
Whenever
on. We just you lagged a little bit, so we didn't get an answer on the last one. You said it's really hydrophilic.
so you don't need much water. You want to saturate where the crystals grow. If you look at how they do it quickly, you want to saturate it. So you don't want too much water. And I think you're putting too much water in there.
You think I got too much water? It's affecting it.
Yeah, you want like it saturated. You want to look at the Epsom salt, magnesium sulfate, look up the saturation where it's saturated, and you'll get crystals. You know, if you put too much water, you have to evaporate the water off. It's just more efficient to saturate it.
No, that's fine because I could set up a second test. So what you're saying is, should I go? So if it's half a cup of water, okay,
Mm-hmm.
should I use 3/4 cups of salt?
I'd have to look up the saturation of Epsom salt, you know. I don't
Because I
know.
went 50-50 before, is what I did.
Yeah, I think that's too much though. Like I said, it's like copper sulfate. Like sulfates gather a bunch of water around them, just sitting there. You wouldn't think about it, but Joe knows copper sulfate has like 8 or maybe 10 water molecules on it that you would have to boil off to get to the actual calcium sulfate. You know, and Epsom salt's similar because it's magnesium sulfate. So it's really wanting to, it's like a sponge for water. It really wants to, hey, I don't like to be dry. I like to be like a fish in the water, you know?
Yeah. Well, what I'm looking for, Jarvis, is I'm looking for it to block the reconstruction of it. Okay. I thought in the beginning, hey, throw some energy in there. Maybe it'll make it go faster. Maybe it don't do anything. You know what I mean? Maybe it'll block it. It seems to have absolutely stalled any process that it had to come back together. But the crazier thing is how clear the water is. No crystal. Not even, you know, when you put salt in water and you stir it up, and then, you know, a little while later, a couple hours or something, you get a little bit of salt on the bottom. You know what I mean? I'm getting none of that.
It's the evaporation that does that, though. As the water evaporates, it like makes these into very small molecules that it's like Tetris. And if you were to put electromagnetic fields while they fall through the water, you could structure it how you want it. It's like a Tetris game with molecules. You know
so
what I mean?
I need the water to evaporate very fast, is what you're saying.
Well, or super saturate it first, and then you don't have to evaporate it. Just yeah. It's just
cut off again.
sorry, I don't know what's going on.
It's all right, man. Look, I'm just trying to figure out this thing. Look, it's the first test. There's no harm, no foul in anything that's done. All we're doing is we're throwing things at the wall and see which one sticks. You know what I mean?
I'm saying think of it like a Tetris game, though. You know, like as the water's evaporating, it's giving these little bitty molecules that you could control with electromagnetic fields. And And the choice is like on a molecular level, it's almost good to use 3 different frequencies. Like Sheila was saying, like microwaves on one level, light on another level, and like X-rays but those frequencies, a normal Tesla coil is too low of a frequency to kind of do anything. It's easier to resonate something if you're too quick than too slow. And a Tesla coil is just too slow to
What frequency
design.
do you have to be in?
Huh? Yeah, like
What
microwave
frequency?
Microwave at the lowest, green
So what's
light.
that? Like a megahertz?
Well, it's a micro. It's funny how they used to measure it, but like take a meter, the length of it is a micrometer.
Well,
So
what
it's
is that? Like so
I think the lengths of
just
it,
throw
I
a
don't
number
know.
out there for me. Like a megahertz, 10 megahertz.
It's probably gigahertz. Yeah.
Gigahertz? Okay.
Yeah.
I'm just trying to see if it's attainable because I have coils that are in the megahertz.
Microwave's actually like the lowest below red that you see. So it's like an infrared vision.
Okay.
But we sense it as heat, which is interesting. We still have sensation for microwaves. It does something to, sense it.
Interesting.
But it's infrared, and then like you want green for the middle of the light, and like the light would be more for the spin. If I was looking at the paper and I was showing you, like, you had the orbit, and Sheila called it the amplitude. I'd rather call it the amplitude than the ripple, where it does the small loop. Okay, let's call it amplitude. I think Sheila's right. Just call it amplitude because you got a wave and it's a little circle around that torus that gives it the amplitude up and down, So Sheila, I like her word better than ripple.
Well, you're just replacing the one with the amplitude, which is fine. It's
right.
The same thing. It's just
exactly.
a value.
Yes, it's the same thing. And Sheila is just right on with it, and she was expressing.
Dude, I'm right there with you. Like I said, we're just trying to figure some stuff out here. We're throwing it at the wall. We'll see what sticks and which way we can go with it. And then we'll also look at, different materials that we can use in certain situations. The availability, gives it to us, we're going to do it.
It's like, think of the guy that made the first compass. You know what I mean? Hey, it gets some use. We can tell what's north and south. What else can you do? You know what I mean? You just think about it, and there's really, as many applications as magnets has, electrodes has too, so it opens up a lot of possibilities. That's what I like about it. It's and it's something to learn to get into this, because everybody focuses on the magnetic field to generate electricity, but unless you do it correctly, which some people do, like Faraday and all them with the Bedini type systems, you can take the back EMF and do all this stuff and run it efficiently, but those are magnetic, and then when you get into electrics, it's weird designs that are cheaper, and plastics and weird stuff, dirt, sand, something you could literally go out in the backyard. If you had an emergency, maybe you can at least have light. Just put a little LED on something where you can whip up together. You know what I mean?
Oh, I can get you some free light outside.
Yeah, it's easy to do that, but in order to leak it slowly too, I had to, when I'm ready to make videos with Sean, I want to do it rapid release, because there's going to be a point where they're going to be like, shut up. You know what I mean? I'll get a gag order, but I want to try to release as much as I can,
Well, like I've always told you, just bring it up to where you're comfortable with and let the rest wait until you're done. You know what I mean? Not a big deal. Check this out. There's a quick, easy way to make electricity. And you ever see those paddle wheels, Jarvis, for the water?
Yeah, those are cool. Yeah.
So get your permanent magnet motor, right? And we're just going to make a paddle wheel. and you know what I mean. We're just gonna hook it to it. Now, here's
Just
the trick.
build a dam and there you go.
Well, here's the trick. We're just gonna use a hose siphon
Tesla loved
in order to put it over top the water wheel.
Mm-hmm.
So we're just gonna get a bucket. We'll take our water wheel. We'll suck on the hose and create a siphon in it, right? And we'll just put it at a little bit of an angle right on top of it. And as it spins, it's going to spin that motor or the generator, I should say. In a permanent magnet generator, guess what? Now I got enough electricity to turn on the little LEDs around my wife's garden.
But
And
what if you can skip the
never turns off?
You can skip the magnetic part completely, though, is what I'm trying to say. When you get to not just electrics, but magnetoelectrics, where you mess with the orientation of it, okay? You can do stuff like that easier, you know, and you can
I'm sure it's easier.
The magnetic thing, it's kind of something you got to conflict every time because it's that back EMF that you know what I mean? But you don't have that with electrics and
in a little paddle wheel, you're not getting enough back EMF to make a difference.
Right.
That's why I said it that way instead of something real big. What you're talking about would activate something much larger.
Right.
So I'm just talking about some cheap little thing, plastic, 3D printed out. You know what I mean? Have some fun.
I like cool projects.
Trip out the neighbor.
I try to think if the power were to go out right now. And I think Gerald thought I was crazy for buying so many pennies. I showed him like a block of pennies. It's like a $25 block. And I went into the bank with a crate because I knew $100 worth every time is like, oh my goodness.
Is he talking about those pennies again? Turning rocks into resistors, man. That's cool.
They're no longer producing the pennies, right? So I'm sorry.
About the pennies again. You lagged. I'm thinking, did he say pennies? And then
I'm sorry, I'm lagging. I don't know what's going on. But okay, so they discontinued making the pennies. So like all the pennies before 1984 were 3 pennies. You know what I mean?
Stuck on those 3 pennies, man.
It's free money, you know.
Well, you have to separate the actual.
I just tripled.
You?
Yeah. I'm kidding though, but mostly I'm interested if the power went out, I can make batteries very easily off that. I just take one zinc base and scrape it on my concrete to get like a zinc, and then like take a 1984 or lower, and then put some vinegar below it, and then you stack it up. And you got light that easy. It takes pennies, but hey. And every time the zinc gets corroded, all you got to do is scrape it on your driveway again to get the oxides off and do it again.
I'll tell you
so
what.
It lasts a little while.
How about you create
a penny battery? It's really easiest.
No, I get it. I'd love to see you create it, make a little video, just a little short video, you know what I mean? Doesn't have to be more than 30
if the power
seconds.
Goes out, you want some light, you know? It's that easy. That's why I really got a bunch of pennies. And everybody's like, why is he getting a bunch of pennies? I'm like, dude, I'm telling you, it costs more to make a penny and then Trump says that they're not making them anymore and the value of pennies went up. And I'm like, I told you guys.
Well,
it's not it's not because of the value, it's because of the utility. If the power goes out, pennies are going to be really great, man. I can pass out batteries like nobody.
Like I said, dude, show us how to do it, because I'd love to take some pennies, pull the outside copper off, and let's do the science on it.
Just having light will give you so much more motivation. If the power were to go out, you had to fill your tub full of water and like, oh my goodness, like
if the power goes out, we got all day to screw with it. So you know what I mean? Just show us how to do it, man, and I'm all good. Let's make that penny work for us.
Yeah, I'm trying to think of a series though. You know, it'd be interesting. I mean, I'm not saying the power is going to go out, but I enjoy thinking like right now, boom, what would happen? What would you do? First thing I would do is fill up my tub and my sinks with water because
oh man, there we go again.
Sorry. I think maybe I should just bounce. I I think it's glitching on me.
It's up to you, man. You can hang out if you want to. That thing keeps lagging. I don't know what you got going on.
Are there any questions in chat?
Let's see. It says use a Zeke washer instead of the penny.
Yeah, that'll work too. Absolutely. But when you get 1984 and below, you're probably out of a block of pennies going to get 25% of those. Okay. But those are 3 cents.
Oh, man.
I know they don't want me to say this type of stuff. I mean, if they want me to shut up, just like Elon, hire me, man.
Well, we're not talking about anything yet. We barely got past the pennies. Oh, man. Yeah, you're cutting out again, Jarvis.
I have no idea what's going on. Sorry.
It's all right, man. They don't like you talking about the pennies.
Yeah, because it makes, I won't talk about it again because I don't want to glitch out.
I'm making fun with you, man. I don't think they care about the pennies. They want the other stuff.
Well, I'm not going to talk about it. It's funny. It's the lowest value of money, but to me, it makes the most value. Like, in my opinion, I think pennies are worth more
Most people would collect the silver.
Why?
They give me $50, give me $1, you know what I mean, in silver. Not the penny. Oh, man. That's pretty funny.
Well, what I was getting at with the you're talking about beeswax used with transformer.
Man, he paused right there. Looks like he just smoked a good riff, man. He's oh.
What do I do? How do I?
I don't know how to fix it, man. You got to reset your internet.
Should I like exit and come back, or
cycle your router?
All right.
Because that's what's lagging on you.
Hold on 1 second.
Hey, Joe, are you cooking?
Oh, yeah, man. That's exactly what I'm doing. I'm making dinner. I figured I'd pop on. You don't have to wait until Friday to hear my 2 cents on why the hell your crystal's not forming.
Oh, well, give it to us, Joe.
All right. First of all, I'm making bacon jalapeno mac and cheese. So one thing at a time. All right, cool. So why isn't it forming? Well, I think that Jarvis is, first of all, right about the saturation levels. You really need high saturate in order for the molecular bonds to be enticed into a crystal formation. If it's too loose and stuff, it'll start forming microcrystals, which will actually just jumble up, but it'll still be in small, very small crystal formations, and it'll take much longer for that to occur because of the amount of evaporation that has to occur for the process to kick off. But I also don't think that that's the sole thing going on. I think that in that case, you introduce the frequency into the water, you're changing the resonance of the water, which it natively will actually precipitate out of in that crystal formation. The water, since it's water soluble, the water actually has everything that it needs in its native state in order to reach a coherent lattice structure. Once you interrupt that, depending on what the interruption is, it could either, form into and accelerate crystal formation or alter the crystal lattice formation into different geometries that would be in line with what it's capable of creating in the first place. And then other times what you end up doing is creating, I don't want to say such a state of dissonance. I don't know that it's such a state of dissonance, but it's kind of like that. where you have a crystal that's forming, but it's actually forming out of a natural lattice state, which becomes microcrystalline. So it's microcrystalline because the molecular structure itself maintains a kind of crystal property to it. But since it's not forming into any greater lattice structure, it ends up just falling out of solution and accumulating in a solid mass of microcrystalline crystal. So there's all sorts of different types of
May I cut you
microcrystalline.
off for a second?
Oh, you were gonna anyway, Jarvis. You might as well. No, no, I'm only playing with you, bro. Of course.
Thank you,
I
Lucius,
think-
for the $5, man. I really do appreciate that. Thank you very much.
Imagine, I would like to study the height of the cell, right? Because as it's falling, it's going through 100-volt potential per meter on the Earth's surface, like just by the Earth. So, like, set one at 1 meter and see if the electric potential alone does something different. You know what I mean?
Well, right. So anytime you have the ambient environment, it varies depending on what natural crystal growth goes through to determine what's the zero as far as the energy densities that it travels through or is created and is concerned, right?
Yeah.
Obviously, adjusting those energy levels is a significant factor, but I think that how it ultimately structures is more to do with the standing wave that's created at a certain frequency resonance that's achieved in the water, and that's directly based also and significantly based on how confined the space is. So that's part of the fraction that has to exist, is that the frequency that's put in must also be in line with the geometry and size of the confinement of the saturate solution.
Would you agree then that you need like microwave light and X-ray kind of things to go there?
Yes and no. Yes, because I think that those things are more native to the molecular frequencies. Okay, but I believe that by falling into something in tune with those higher frequencies, you could effectively do what, like Nathan had been saying all along. It's like when you give a push every so often, that amplifies the effect of what's already natively there. So as long as you're not disrupting that, if you're just adding a higher energy state at a frequency that's in coherence, then at that point you're not going to negatively affect it. If anything, you're going to positively affect it. As far as at least accelerated accumulation would be concerned. That's just my 2 cents.
I got a lot to learn, apparently.
Yep, and I don't even know what I'm talking about, by the way. I just make shit up as I go along.
Only Joe.
You would think I thought about this at a time or two, or maybe opened a book one time. Nope, never
Well,
happened.
you know a lot more about crystals than I ever would, and the structures, that's for sure.
Yeah. I mean, so the standing wave thing is interesting, right? Because if you imagine creating a standing wave in an isolated or condensed area, okay, so you're dealing with very little energy in as an oscillation, and then you're actually dealing with it bouncing off all the surfaces, and then how it reculminates and interferes, right? That would effectively create standing wave patterns. Depending on the frequency, that would reach different stabilities based on the size and geometry of the confinement. Now, the thing about that is this, okay, and this is where what Jarvis was saying is actually critical about how the higher frequency levels affect it. Now, the standing waves that you'd create at those lower levels, okay, are exactly analogous to what it would be creating at the higher levels, but it's more spaced apart. Okay, because you're looking for molecular structure, okay, to be affected, you have to hope that at those lower energy levels that you're also bringing that standing wave, not only what you see at the surface, so to speak, as far as like it vibrating off the sides and such. You hope that that goes down into the molecular level of the water itself, which would then be the thing that would be capable of inducing a reorganization of this of the supersaturation, because ultimately that supersaturation is a suspension. And once you reach the supersaturation, the crystals are going to want to fall out of that saturation with much less evaporation because it's not supposed to hold that much solution in the first place.
Mm-hmm.
So that's sort of the idea here.
And I like that there's certain combinations you can do to make it endothermic with those crystals, like ammonium nitrate. Where you can have like cold pack material and it actually absorbs heat from the environment.
Yep, that's true. And I was talking to Nathan earlier about ammonium nitrate, actually.
It's one of those things, but that's probably not something that's meant for the general public.
Well, I mean, honestly, in certain forms, like, it'll still actually crystallize and have endothermic reactions to a certain degree, but become much more stable. And in those forms, they actually sell it in part of like crystal making kits for kids. So, like, it becomes a little bit safer at that point. It's how it's used as a fertilizer.
Well, it's like a stoichiometric measure. If there's not enough gas in an atmosphere, I couldn't light a lighter and explode. It takes a certain amount of mixture of the air and the gas to get to the point.
Yeah. Well, it comes right back down to the fact that chemistry is all that is physics at a smaller scale, and done with mixing materials to bring in different stable resonances than than previously and stuff, and that's what leads to these reactions.
Well, you said something important though. Microwaves is the distance between each time it has the what do you call it, or the Sheila called it, the increase of energy, right?
Amplitude.
So it's just the distance between them. So if you put it in a microwave, it's like super small. So it makes sense when you're talking about how it's doing it on a very small level. You know what I mean? Making that form.
And that's exactly the point of the high frequency. It would actually be able to create, once it's in tune, those certain like you always say, it's like the music scale, right? Your key of A, okay, whether it's this frequency or a much higher key of A, is actually going to create the same repeating standing wave patterns based on the geometries involved and the so that's what I'm saying about it. It'd just be a smaller scale. It'd be able to repeat smaller because it is smaller.
So hold on. So if I did build a crystal, the actual crystal structure would be bigger if it took on the frequency of the Tesla coil. If not, it'd go back to the generic frequency, which much smaller of a scale that they're building out in. Because I'm going from kilohertz to, on my Tesla coil to.
Okay, so again, I don't think it has to do with building out bigger. I don't think that that's the right way to think about it, because those bonds have to be made at the molecular level regardless, right? So, in order for the crystal to form. Now, in order for it to form coherently at both a micro and macroscopic scale, it'll do that natively, right? So the whole point here is that you want to be able to induce something that's either going to be a lower frequency and act as a push, an amplitude increase, okay, an energy increase to what's already going on, okay, to be able to accentuate what is already going on. Or you're going to find something that is in a form of fractal coherence based on the stability of the molecular composition that is trying to be formed. Okay, so it could be a fraction of what's already there. So Epsom salt forms a six-sided, crystal, generally speaking. Okay, that's its lattice structure, is six-sided, like quartz and other things, right? But what is six? Well, six is also divisible by 2 and 3. So there's certain seconds and thirds of the sixth of the frequency that you'd have to be able to hit, that you could actually hit to actually change how it structures, because it'd be doing it fractally. So it would be alternating in that case.
Okay. I think it was interesting that Sheila emphasized 8. It's one of the first times I've learned since Egyptians would use pi as a ratio with 8. 6 is really cool. I like to say, like, okay, we just so happen to have 5 fingers on each hand, so we go with the decimal system, right? We got 10. Yeah. What about those aliens that got 3 on each hand? That'd be a
Well,
sick.
okay, so that's great you brought that up. That's why 12 is so important. Okay, 12. Okay, because that's what bridges the gap of things generally, right? So if you think about a foot, or better yet, even an inch is even better, right? So an inch is a 12th of a foot, but then you could break down an inch. And how do you do it? Well, your biggest denomination is going to be a half, or if you're looking at holes, like single parts of holes, right? So you can break it into 2. That's your biggest part. You're going to get a half. Then it's going to be a quarter, an eighth, a 16th, a 32nd, a 64th. That's how you break down an inch. Now, if you look at those particular numbers and how they're related to 3, or and how it's fractal of that, you realize that the ratio is all consistent across the board. It's a clean break of everything.
Yeah,
So
3 is kind of basically the root,
3 is the root, because 3 is the root of 12 is the thing.
Yeah, 3. Yeah, that's what I've been harping a long time. But like, you can actually take a circle, and without a square, you can divide it into 6 equal sections with the flower of life, just using the compass again. You know what I mean? You don't even need a square. So that's why I like 6, because hexadecimal is like blues scale. I like the blues scale. Rock and roll is all hexadecimal. You know what I mean?
I'm there with you on the blues. Nice.
Yeah, but those are all hexadecimal based, So it started with the blues. So yeah, that would make sense. But the hexadecimal, and Sheila, this is what I'm saying. She emphasized the 8, which is ancient, very ancient. I haven't heard anybody emphasize 8 since her. You know what I mean?
Well, the 8 is the difference that doesn't fall into the scale, right? So but it still does. So when you're talking about halves and quarters, right? It's that quarter that then goes to the 8 of the halves and quarters. That's the whole thing. That's how it fits in. Because other than that, you start looking at it and it starts to build by 3s.
I picture that as the octave, though, is I think where she's going in music. The 8 is the octave. You know what I mean? So,
right.
And a lot of people use 7-note scales as the major scale or the minor, but then there's hexadecimals, what I'm saying with rock and roll and alternative and all that different type of music.
Right. Yep, it's true. But the music all plays a role in this, because that's actually, when you're forming crystals, that's really what you're looking for. You're looking for oscillatory energy, which is what's being produced anyway, regardless. But that's what does it, is the vibration. It's the vibration that holds everything into the stability. It's all vibration, no matter what, down to its smallest scale.
Go ahead. Oh man, I'm sorry.
I wanted to tell you about an effect that was going on in my garage that's now gone. So I ran this thing 24 hours, right? Now, you give me my Tesla coil, it could be the water. I have no idea what it is. Okay. In the room, it felt salty all day.
Okay? Felt salty.
Yeah, it was just weird. It was like it's at the beach. Okay. You know what I mean? When you get up to the beach, that little air that's in there, and it felt a little bit of salty. You know what I mean?
I got it.
Now, it could just be that I have salt open in the room. It could just be, you know what I mean, that the Tesla coil is going on into water. You know what I mean? It could be a Tesla coil going on all night long, which I'm not used to.
So it could be an ionizing effect also, I mean, of the ionization of the salt crystals within it.
Well, there you go.
What do you think you smell when you're at the beach? There's no salt physically in the water, but there's certainly a lot of ionized salt water.
Well, there you go. It's got to be something that just has the same feeling to it. I cannot describe it physically. It just has a weird feel. It's like, how I put it this way. You know how you get dehydrated? It feels like the water's being pulled out. You know what I mean?
Right.
It's kind of like the same feeling I got.
Like a desiccation, huh?
Yeah, all night when I was working, I got the same feeling. And it was just like in the beginning, it makes you sick. You know what I mean? It was just weird. It might have just been the Tesla coil being on for so long.
Right. That's interesting, though, still. I mean, nonetheless.
Yeah. So, anyway, I just thought I'd put it out there so in case you do the test, you'll kind of see the same thing. But I'm looking forward to that thing, man. I'm going to try it again just as the hot water and the salt with the same value and let it run 24 hours. I just want to see if it did anything. You know what I mean?
Right.
Same structure, same setup, just naturally do it. Did I do something wrong? You know what I mean? Because if it doesn't produce a result then I screwed up. And then I'll have to saturate it more with more salt in the next one. You know what I mean? To get the process going. So,
well, I mean,
I'll figure it out.
the good news about it is that, like, with a little bit of patience or even heating, you know, like realistically, you could continue the project. I mean, you could just by applying a small amount of heat to it will greatly accelerate it without necessarily disturbing the frequency that you're inputting into it all too much. Like if you have one of those like heater
plate?
things that you put, like a hot plate or something that something that's not going to boil the water, but it's going to raise the
How about
temperature.
a coffee thing, like a little to warm your coffee in the morning.
Right. I mean, you could use that to just simply give it a jump start. And then once you start seeing that water level go down, say to yourself, all right, I'm at a much better saturation level now. Now I can,
I'll
kick
give
it off.
that a try.
Well, I mean, if it were small enough volume, you could just microwave it before you.
No, it is. It's in like a little 1 cup container, so probably
Well,
about this big.
What I'm trying to get at is you want to look up the saturation level because you wouldn't even have to evaporate that much off, because once you're at the saturation level, it doesn't take much heat. You could use a heat gun, A heat gun's actually good because the wind will evaporate it off as you're blowing it with the heat gun.
That is true. Just check your vessel on that before you start.
Yeah, I get it. I just want to see if there was something that in a controlled environment that I have something different than what I was adding here. You know what I mean?
Mm-hmm.
That I have any effect. That's all I want to know. So I don't mind doing the test again, letting it sit for a day. That's not a problem. You know what I mean? We'll just throw things out and see what comes up, and we'll try different salts because, I mean, who doesn't want to build a crystal and then throw different salts in it and see what kind of crystal you get after that, right?
Hey, it's fun, right? That's the whole point. This is the best kind of experiment,
It is fun. It's learning, I think it's progressing to where we need to go, but without having a foundation, like thinking about these things, you can't really get to where we need to go.
Yeah. I mean, you could probably get some, like, again, it depends, and I'd have to research it more, but like there's certain like simple, easy, cheap devices out there that have adjustable ultrasound outputs and stuff like that. I think that in a case like what you're trying to do,
they have silent alarms. Look at a silent alarm. Look at a silent alarm. There you go.
Well, yeah, I mean, we're right. I mean, you see what you could use, because I think that ultimately a transducer in this case bring that oscillatory,
like ultrasound is, that's where,
if it's adjustable, then exactly what you have to bring. But I think that a transducer in the water is ultimately going to give you what you're looking for, probably a bit easier than the Tesla coil, because you have to make a lot of energy into it in order to create that same effect that it's going to give you.
When you say transducer, you're just talking a piezo disc or an actual transducer?
I mean, an actual transducer is nice if you have a little wand hooked up to something with a potentiometer, or whatever, where you can adjust it and that's nice.
I have an AC board, and it has a transducer on it, the big metal one. That's what I'm asking. And it's used in there to break apart stuff off of your parts. You know what I mean? In the water.
I got you.
Yeah, I have one of those, and then I have the piezo. So that's why I was trying to get the distinction, so I know which one you're talking about.
Yeah, I mean, realistically, I think that any of the above would sort of work. It's just really a matter of again getting that higher frequency into it, but also like being able to adjust it, because that's going to be critical. Having something that's in dissonance and creating a poor standing wave pattern, it may work in one context and not another because, again, of the confinement and geometry. Now if you get some standing wave patterns, and this is good to know, are actually fractally repeating like a lattice, which is why it works in the first place. So if something this size works, let's say, and that size is 6 inches, then something that's related to that measure would also work. If it's if it's 12 inches or 18 inches or something in between, because it's repeating and therefore it's having that same, as long as it has to meet the same ratio. And that's been what I've been saying all along about the geometries of everything. It has to meet that same ratio.
Yeah, but you can kind of, even Tesla, he would just separate the plates to get the exact frequency down. You just get an estimate from the dimensions of it, and then like all you gotta do is like use oil and like a little screw, and you can tune it right in there, as long as you know the dimensions. And it's cool. I love what's his name, Master Ian, or
Master Evo. Is that what you're talking about? Oh man, cut out right there.
Oh man, can't even pay a compliment today.
Wow.
Master
See,
Evo had a variable capacitor, and that's what I'm saying. That something like a console like that is very.
What? Haven't you been watching the show today, man? I
I'm
mean,
sorry.
this is like this. This is what Evo has.
Yes. Something like that's very handy. And all you got to do is figure out like a rough guesstimate of the dimensions you're working with, the aquarium, if you will, with the Epsom salt aquarium. Work out the rough dimensions. And I didn't see you guys debate about AI or not, but it kind of skips the bullshit for me. Like, I don't want to look at a video for like 20 minutes to figure out like how to calculate the dimensions of this. And it gets straight to the point. So the thing I like about AI is it cuts the time. If I want like a specific question, it'll break it down and give it to me instead of having to try to watch a video about it.
So that was actually one of the key points that I brought up in that discussion, was that it's
Good,
really, really good for comparative purpose. So if you bring two unalike things that you already envision there being a relationship to, or if you're trying to bridge the gap between the relationship of two things, you could ask it these questions. It will dig deep and generally put you on the right track. Like,
right. Compared to like watching like 1 10-minute video, not precisely getting what they're saying, and then watching another 10-minute like at least it gets to the point. It really focuses on what you're asking it. That's to save the time to get to the point. It may not be correct every time, and I've noticed it's not been correct every time, but it's getting better.
Yeah, I agree.
Once it gets to the point to having like I think they said it's a 165 IQ right now, but like imagine when it's like 250, and then you just have something you can toss a question to, and they figure it out. It's a 250 IQ. Okay, I trust it. 165, I kind of trust it. But it makes mistakes. So at 165 IQ right now is kind of the baseline. But dude, it's gonna, in the future, it's gonna be something you can utilize, in my opinion. And I got to watch what you guys said about it. I don't know what the conclusion is.
No, I don't think we got anywhere. Joe likes it. I don't. And that's really good.
Yeah, it's hard.
I gave Nathan a lot of credence on a lot of his points that he made, for what it's worth. Like, I mean, at the end of the day, there's large potential for misuse. But there's counter arguments to every single piece of it.
And imagine, like, they say quantum computers can basically break any code. So cryptocurrency would be useless if you have some supercomputer that uses quantum computing and can break any code. The whole point of a cryptocurrency is to cryptographically confuse anybody that tries to own it. And then you got this supercomputer cracking it like 2 seconds. Like, how do you get value on that? You know what I mean?
I know that's why they're trying to bring it into the bank, I think.
Yeah, but this crypto AI, right? As soon as it can crack it, it'd be like a miner that hits gold every time they go to a mountain. Like gold, 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 gold. It could just stockpile all the gold. You know what I mean? Once it cracks that code. So in the future, it could lose its value like that because AI would just own it like it's Fort Knox.
Well, you better invest in some more pennies then.
That's what I'm saying. At least I got some pennies.
Yeah, I mean, I think that the other side of that coin, and I know the whole point of this wasn't to talk about AI, but you know, I think the other side of that coin is the fact that if one can do it, then a lot of people can do it, and a lot of entities can do it, and that means that it's all happening, and that means that these things are then just in competition with them others, and it really makes it no different right now than market watch proxies that literally have their input settings to watch certain trends, set their own figures, and then buy and sell based on those trends. What's the difference? It's faster than you can look it up and think about it, and it knows it instantly, and it makes a decision, and it doesn't. Right? That's already existed for 20 years. So, you know, like we've already been in that world. It's just going a little bit wider. So your ability to sit there and track and this and that, you'll never be able to keep up with, you know, everybody doing that the old way. That's all.
Yeah. It's going to be a very interesting time coming up. It could be good or bad. It's hard to tell. I think it's going to be good though. I feel like we're going into, like, we had the dark ages already, you know. The Indians, they believe in the Kali Yuga and getting bright after. We're getting to the point of really trying to be good. And
yeah, no, I agree. I mean, things are definitely they're going. I ain't saying how they're going, but they're going all right.
Yeah, it's like walking the razor's edge, isn't it? Either you can walk it or you're going to get split in half. And it really depends on, you know what I mean, what your core value is in the end.
yeah, like, but if you have faith in the goodness of humanity, you know, I know there's wicked people out there, but I believe there's more humanitarians than people that just want to hate. There's more good, I guess I would say, than there is bad, in my opinion.
You know what I think? If people like get into the crystal and they see that it genuinely puts off energy, that it can be used in a higher structure in society, things like that, and it ties back into ancient culture like it's doing right now, then I think people are more apt to have a good faith in everything that's going on. Because you're linking your past with your future, and it's starting to make sense now. You have a sense of worth in society. I think you can't underestimate that. I think when they try to cut us off and block us in Egypt from finding the right stuff, they hide things from us all the time. That's when society falls apart.
Yeah, it's
I don't disagree with that at all, man. That's well put.
It's hard to say because
this is where, you know, being of that higher spiritual caliber and understanding kind of comes in big for people. You know, you need to be able to see what's going on.
I was gonna say the secrecy is tough because the other side is privacy. You know, if they were all open, there would be no secrets, but their privacy would be invaded. You know what I mean?
Well, that's what I'm saying. Like the crystal
It's a weird thing.
What's the harm? What's the harm in telling people what it does? You know what I mean? There isn't any. People have already believed it for so long now. You know what I mean? What it does. Now it's just giving credence to what they were saying. It's just helping them, you know what I mean, say, hey, there was a higher state that you didn't look at. It's, you know, it's taking the mystery out of resonance. It's understanding something better.
Joe Fuchsius?
Yep, I've been cooking. Yep.
Oh, by the way, somebody asked, have you seen the movie Beekeeper? I've seen it. I like that one.
I haven't seen that one. Yeah, I haven't seen that one.
Yeah, it was pretty good, man. Oh, Jarvis disappeared again.
Oh, damn.
Wow.
The hell of a time we live in, I tell you.
They're changing, huh?
Yeah.
Yeah. I just, I want it to be something where when we find out something, it really ties into ancient culture. That's kind of the biggest thing for me. They had it, and I know that they did. And a lot of people are naysayers out there and don't get it. They don't see the connections here.
Well, right. I mean, you're saying about the ancient culture, right? You just said about, it would be nice if they just came out and said like the stuff about the crystals. People have believed it for millennia, and we're here to tell you we know it's true. The funny thing about it is, and we've kind of touched on this before, but like deductive reasoning tends to be very difficult for people.
Yeah.
I feel like, and once you understand the fact that everything that fuels the technology that has all recently rolled out and every innovation and how it's all material science based and what it is that it's using and or trying to emulate is all crystals, okay, and circuitry based on crystals and different lattice structures. Okay, once you can see outside of the box and see it for what it is, it hasn't really been a secret all along. It's just not been talked about in the light and regard that you would have hoped they came out and said, to the extent, but it's there. So if you see that crystals are out there doing all this stuff and with technology and stuff, you could then go ahead and apply it to what you believe they do metaphysically or otherwise, and understand that there's a lot of credence there, right?
Mm-hmm.
So deductive reasoning, it's invaluable.
Yeah, I don't think people have as much of it as they need. That's all it's saying. They need somebody to tell them and reaffirm their thought. I mean, I hate to say it that way, but a lot of people do.
Right. Why be able to, why decipher and extrapolate information off of things that you see and connections you can make, when you need somebody else to like tell you that that's the case or else it's not true, right?
Mm-hmm.
Keep on winning, people.
Yeah. Yeah, people do that a lot, man. They watch the news to get confirmation of what they know, and then they don't get it. Oh.
Sometimes I talk to people about different things if if they kind of ask or touch on a subject that I might know about. And it's funny because most of the time I'll explain it in a way that they understand and they could actually relate to and be like, wow, I never thought about it like that. But what's funny is that probably the most common thing that I hear from people that really don't have much of, knowledge, whether it's on like psychology or something spiritual or technology, is they're like, that makes a lot of sense. It's just like I was taught something so much different, and it's like, yes, yes, you were. So then it's like, well, did what they tell you make sense as far as what you see and think, or do you just keep on wondering? It's like, no, I've always just kind of kept on wondering. It's like, well, there you go.
Yeah, so it didn't stick with you no matter what.
Yeah.
So, what do you guys think is consciousness? Sometimes I think it'd be best to just boil down definitions that we're not really, to all agree. I was thinking a debate bot, like a debate mate, kind of like if we disagree about, longitudinal or scalar type discussions, we could pause and be like, okay, debate mate, who's right, blah blah blah. It'd be a third party give us an answer. So like an AI debate, like, okay, he thinks scalar is this, he thinks scalar is that. It could be both, they could both be right in their own minds. But something like that would be interesting because there's no third party, and I just want to be able to like just define it in a sequence that just can be proliferated, on fact.
I disagree with that because of context.
Yeah.
Everything has to do with context.
It's semantics. But whenever somebody tries, like if somebody says, for instance, a relay instead of a diode, I won't say who that was. You have to call him out. I mean, I wouldn't want him to go on thinking a relay is a diode.
Well,
You know what I mean?
there's mistakes of
Yeah.
terminology, and then there's a dispute over, you know, something that's multifaceted and its use as to which it falls into. And at this point, fighting over
It
words
definitely should
is the
not
dumbest
be
thing ever.
called a diode because it's not, is what I'm
Well,
saying.
there's certain, right. I listen, I get it. A bicycle is not a car. But they
You know,
are both forms of transportation, right? So
yeah.
you gotta realize.
Yeah.
I had told Joe a long time ago we should get a physicist that comes on the show for just 30 minutes and tell us we're all full of shit. You know what I mean? For everything that we say. Yeah. Let's have Jack on to say you schmucks are full of shit. That's what you are.
Jack will shut us up. You
But
guys
that's
don't know what you're
all
talking
that will
about. Okay,
happen.
listen. I've been at NASA. I launched a spacecraft, and he's like, yo, let me talk for just a second. And you're like, dude, you've been talking for 30 minutes, but okay, you can have another second.
Oh, he says, okay, hold on. The top physicists don't like the word scalar because they don't understand it. Just like the gravity word is still all relative.
Well, that's what I was trying to say
I don't understand gravity.
With my ripple idea. I agree to call it amplitude, like Sheila said. Like, that's it. You know what I mean? But we need correct words to do the, you know what I mean? In my opinion.
Okay. I just describe things.
Yeah.
If someone
Which
comes
is
up
cool.
with a definition for me,
I can interpret it and say, I think what you're saying is this. You know what I mean?
I don't know. I'm gonna give you the straight dope, Jarvis. Wasting time on specific hashes over words just so everyone could be on the same page when we're all describing hypothetical and you know, like, sort of provocative subjects that are purposely undefined, and then to get caught up on this side of things where we're describing things in an articulate manner
but they
properly
are defined. They are defined, and it'd be like me just saying, okay, every relay is a diode, is what I'm getting at. That doesn't make sense. Like, I can't allow that.
I'm gonna squash this right now. Okay, if you're in the fucking jungle of Africa, okay, and all of a sudden this thing runs out of a hole, and no human being has ever seen it before, therefore no mouth sound to describe it, okay, and it looks like a cat. What do we do? You know, until we capture the thing, explore it, and see exactly what it is, and realize we've never seen it, and all these steps and processes to figure out that no, this is something new, right? We end up just calling it a cat, and then in the end, you find out it wasn't a cat at all; it's just something else. Well, yeah, but we're still in the process of defining these things. They are not defined. We're using words that already exist to try and articulate these phenomena and ideas that we have that, you know, there are certain meanings, and there could
Right,
be
but
wrong
all I'm
things
saying
used.
is
But the
don't
thing is
be
that you
pissed
can't sit
off
there
if
and
I
call the
cut
thing that
you off.
popped out of the hole something specific if it's never been called anything before in a published journal and given credence.
It has been called before. It really has. It's just, I know it's a matter of semantics, and you know, but I wish I could call like anything what I wanted and everybody else understand what I'm saying. But I could, you know, you can call whatever you want, but if there's no like debate mate that agrees what the definition should be, and we just settle in like that's it, you can't, you know.
So if there's a disagreement, so if there's a disagreement, we leave it to an AI third party to decide what it's called.
Any third party. I was tossing that out there as an
All
example.
right, gotcha. I don't waste time on words, but I think it's funny.
You know what? Here's the thing. I hope they don't understand me. I hope they don't understand me. Every one of these a-holes turns around and puts my stuff in the chat GPT and changes all my words.
That's a
They
good
say,
point.
oh, he said field, so that means electrons and holes is what he kept saying. He kept saying he got his electrons in the hole. You see what I'm saying? That they changed it.
That's a good point, man.
Just like, you know, they describe
well,
Tesla,
for
and they go,
the
Tesla
spectators,
said all the electrons went here, and you go, Tesla didn't say that. He didn't give a F about your electron. You know what I mean?
Yeah.
But they continue to say it because it's simple things that physicists say now that they say that these people did, and they didn't say that at all. They disagreed with that method.
yeah, all I'm trying to say is I'm trying to help gather the viewer intelligence. You know what I mean?
Yeah. I mean, yeah, man, I don't know. It's one of those weird things, brother. Like
yeah,
you've talked about Rosicrucianism and stuff like that before. You've talked about occult things. You damn well know how these things all tied together, and you well understand that. And you go read an occult text, and the words are so cryptid in there as to what all the meaning is that there's a reason that there's never been set ways to describe this stuff is because it's not so simple.
it's
And that's
true.
it. That's it. So,
Okay.
like
I'm cool with that, man.
that's
I'm
sort
cool
of
with that.
the whole thing. It's hard. If it was not hard, those texts wouldn't read like that because those guys wanted the word out, but
Yeah.
only to those that can understand, right? How do you understand other than descriptive language? That's it.
All that means is like if you're watching, you have to really pay attention, because we'll call something that may not make sense, but if you've been watching, I guess you can understand what they're saying, and I'm totally with it.
Yeah.
You have to have some, like, I'm afraid I'm gonna be gagged. Like, honestly, I feel like they're gonna gag me very soon, but I'll keep trying. I mean, because that's my passion, is to really help, and I'll do what I can. But once I'm gagged, I can't do anything. You know what I mean?
Yeah. I mean, honestly, it's one of those things. Would it have happened already?
Maybe, yeah. But once I start rocking and rolling, they're definitely going to. I haven't even started. You know what I mean?
No, they're not going to gag me. They won't understand me. They just call me an old redneck.
Yeah.
that old fat guy out there doesn't know anything.
Right. Don't
Until I start building it, and then they go, "Oh crap, we should have listened."
ever undervalue don't ever undervalue the ability to sound like a moron who somehow makes sense. Because you know what I mean?
Yeah. What you cooking?
Jalapeno, bacon, mac and cheese, and it's done.
Oh my goodness, that sounds
Done.
really good.
Oh, what's that? See my camera for you.
What
Oh,
kind
yeah.
of
Well,
cheese?
maybe that's why I don't patent
Every
things,
kind of
because
cheese.
they wouldn't understand it either. What is that, mac and cheese? You said? Let's see what he's got going on there, Jarvis.
Oh,
And it's got some red jalapenos, green jalapenos, heavy cream, butter, provolone, Parmesan, American. It's starting to string up a little bit, so I did it all right without clumping together, and it's still wet. So yeah, I think I'm gonna eat that.
Yeah, that's like a 5 cheese, dude.
Honestly, I was actually looking to get rid of the cheese in my fridge. Is sort of it went outside on the
I do
4th of
that too.
July for burgers and such,
Yeah, I
and
do that too. It's like
it
I
got
gotta
melted
use
into
it.
blocks. So it was time.
I do that too. I hate letting food waste, man. I'll try to whip it up too. Where's
Yeah.
the jalapenos?
They're in there already. I cooked them into the oil, so the flavor of them gets throughout the entire thing. Like low temperature sort
You
of deal.
cook them in the oil? Nice. Yeah.
Yeah, you got to let that capsaicin get into the oil, then it just goes throughout the whole thing.
Yeah. Nice.
See, this is why you need a Joe's apron that says "Thanks, so do that."
That's right.
So when Joe goes to go cooking, you know what I mean? He does it in style.
I'll get there. One thing at a time.
Check it out, Joe. Look, I got my Gravity Flyer shirt on.
I love it.
I love that shirt, man. I love the color of that shirt.
Yeah.
Look at that. It's
And
awesome.
The letters are like the clouds, kind of.
Yeah.
That's cool.
See if I can't do this without burning myself, huh? Hell yeah.
Oh,
any
yeah, look at that.
chat questions?
Cheesy.
Nice. Yeah, it looks cheesy.
Oh yeah. I don't even want to know what the caloric content on this is because I was like I said, bacon grease, butter, bacon, multiple kinds of cheese, heavy cream.
Oh. My
Well, it's fair enough.
granddaughter loves the bacon. She hates the sausage, but she likes the bacon.
That's strange.
She's like, oh, bacon? I'll take all that and then some more of that, right? But then I go, you want some sausage? And she takes it out of her mouth and just throws it. And it's like, no, thank you.
Wow. Like, is it the way the sausage is cooked? Maybe it,
No, it has nothing to do with the cook level. It's just she just doesn't care for the taste.
that's strange. I love pork, man.
Yeah, me too. Who doesn't? My God. Literally.
Everybody has their own favorite.
I was trying to say the other day, it's kind of funny we call it a hamburger though. How did that start? Like, are we really that dumb to call it ham? It's beef.
Oh, come on. You know how it came about.
No, I don't. How
Hamburg, Germany, man. They used to sit on the meat in cavalry, and it would tenderize and crush up the meat and stuff, and then they would cook it that way and eat it between.
But was the
bread.
meat pig? Like
they
ham?
sat on this stuff?
No, it was usually beef. I'm pretty sure that's how that came about. Germans aren't as big on pork as we are.
What I'm getting at is why call it a hamburger when it should be like a cow burger? Because ham is pig.
Oh my God, Jarvis, it's because it's from Hamburg, Germany.
Okay.
Oh.
Well,
okay.
hold on. See, you wouldn't want the hamburger if it's been under my ass. I'd fucking fart all day on that thing.
I wouldn't want it under my ass either, or nobody's ass for that matter.
Why did they do that?
Well, the Germans are a little sick like that. They're into that weird shit.
Man, they're weird.
Scheiße.
I've heard of them. The funnel you take. I've heard of them putting it up their butt and doing that.
Oh my God.
That's nuts.
Yeah, well, dressed in leather. Anyway.
Wow. We just
Let
went
the
way off the
Germans be
rails.
the Germans. I didn't know it came from Hamburg. Thank you. That really makes sense because I was like, it's a cow. It's not a pig. Why do we call it a hamburger?
Well, why do they call a Frankfurter Frankfurter? There ain't no Frank in it. At least you hope there's not. Back in the day, you never know. We used to love to make sausage out of all sorts of things.
Well, what do the English eat? Spotted dick?
Mm.
I mean, what a name to give something, huh? It's like herpes on your wiener. It's just not, doesn't sound good.
No.
Yeah, no, not at all.
I'll pass on that one.
Yeah, but they're a bunch of fucking idiots over there. They call potato, they call potato chips crisps, and they call or chips crisp, and they call French fries chips, and they're just all messed up. And then they think that it's a good idea to pour vinegar on it. Like, I don't know.
Yeah, everything got vinegar on it.
You gotta have a douse of vinegar or Worcestershire if you're in Russia. It's like Worcestershire kind of.
Yeah. And then you have to hear them pretentiously tell you how the metric system is somehow superior.
Oh God, show them that again, dude.
You know what? I would actually like to battle you as your antagonist on that.
No, you don't.
Yeah, I do. In one episode, we should do that. I will. I'll battle you, and I'll tell you why the metric system's superior than the empirical.
Oh,
sure.
So funny.
You should understand that I'm a professional negotiator for a living my entire life against high-end New York City lawyers on huge cases. You ought to realize that, if anybody could sell a bag of ice to a penguin, it's me.
I'm putting it out there. I think it'd be
Fair
fun.
enough. No, listen, I'm down. Whatever you want. Do it on your channel, bro. Fire it up.
Oh my God. You guys debating stuff, man. At least we're not eating snails over here. That'd be bad.
Yeah,
Those are gross. I don't know what they were thinking. Oh,
I don't know. I feel sorry for you guys not having any of this though, because this is good.
Well, apparently it's good because you keep shoveling it down like it's going out of style.
No, it is. I don't know how to sit down and relax.
You keep eating it, the jalapeno is like.
Well, don't you have to have that cheese like solidify a little more?
Oh, it is already.
pretty
Look,
wet?
it's both perfectly creamy and mildly stringy. This is my trick, man.
Mm.
You see, I use the American cheese because it has emulsifiers in it. You see? So you could further supersaturate the milk without it separating or getting too stringy because of the emulsifier. Science to my benefit.
Hmm.
Mm-hmm.
I used heavy cream in the last mac and cheese I had. It tastes really good, except for it just feels thick inside of you. You know what I mean?
Oh yeah, it kind of does, but
Bog Irish, I have to say that's pretty insightful. I picture that as like a cantilever type of ledge, and the sound you're talking about, the ledge probably does matter. That's yeah, you're one smart.
I can't read that. Standing waves. Do I think? Can somebody read that?
Do you think there's an acoustic relationship between the gravity flyer hover heights, the Tibetan monk rock levitation? They seem to respond to a plateau like a node.
Yes.
I think the answer is absolutely yes to that. Of
Yeah.
course, man. Yeah, man.
Yeah.
Right on.
Yeah.
That's the point.
Yeah.
Yeah. I think they're all working on the same thing. We just don't know it yet.
Nice. It's cool that everybody's thinking the right way, though. I love it. Hey,
Oh, Ian. He said the spotted disc tastes good.
Spotted dick. Yeah, well, no. I've seen it before. It looks good, but I wasn't about to say it on live.
I'm gonna look it up. Spotted dick? Is that
Yeah, it's
what?
like it's like pudding, man. It's like, not
But-
our version of pudding. Their version of pudding.
It's got like raisins or something on the top, doesn't it? Some kind of weird thing that makes the little spots.
My whole family growing up, they're all Scottish, like off the boat Scottish. Most of them not even from here. I just spent my whole entire childhood making fun of them for all sorts of things. I don't plan on stopping now.
Oh man. I can't even order donut holes when I go down to the donut shop without laughing my ass off. I mean, everything, man. Oh,
I'm gonna share my screen for a second. Spotted
it's dumplings with what is that? Salty. I can't read the word.
And
Something
raisins.
raisin.
I knew the raisins part. That's what makes
Yeah,
it spotted.
tasting. Is that
What
like?
do we look? Oh, there it is. Okay.
It's got maybe Irish. Like, what is this?
Oh man.
Yeah, that's what I was saying. It kind of looked like a pudding, like their version of a pudding
Well,
You got
it
the
looks
name
like
right.
cake.
situation.
It looks like a raisin cake.
Mm-hmm.
Oh, here's the pudding one.
Oh, well, they're not giving you that version as a foreigner. They're giving you the one that looks like the dick.
Yeah, right. You get spotted
Yeah.
dick out of a can,
Yeah.
That's why.
a long can. That's like the UK equivalent of like cranberry sauce.
Oh my god, dude. They have so many weird names in English for stuff. Oh, I can't even say it on air what they're called. They call things different names, that's for sure. Let me just say that.
Cookies are not biscuits.
No, they're not. And I think it had to do with sausages or something, and they called it oh, I can't say it. Just agates, if you understand what I mean. It's totally different word, and to us it's a different word than it is to them. And they say we eat them all the time.
They call it fage, though. That's how they get away with it.
We can't get away with it. Well, okay, gonna get a bunch of flags outside of our house if we do it.
It's fage. That's the.
You're just talking about food. That's the bad thing.
It's like how people call Target Target or something. It's like
One's like faggy. What's up?
pretty
That's what
much.
they call them.
Well, I mean, listen, they go outside in London. They go smoke some fags. Like
Yeah, that's
that's
true.
what they
Though.
do.
They
I'm
call
not.
them
I
fags.
didn't make this up. This isn't my expletive.
That is true. Yeah.
Oh man. Yeah, some strange names for some foods, man. I'll tell you that right now.
Mm.
Oh man. Wife just said she wants me to make dinner. Oh.
Well, send you my leftovers, man. I ain't gonna eat it all. Be a little cold by the time it gets there.
Replicator.
Yeah, this is where we need the replicator, man.
Yeah, transporter.
If I could send it to you, straight up take credit for it. She'd be like, man, I don't know where you're doing this from. You didn't even go to the store.
You got like a drone delivering it to your roof. Like, well, now I gotta climb my roof to get some pasta.
No, we need 3 orbs. That's what we need. 3 orbs.
Hey,
I heard Pizza
we're
Hut's
not mature enough for a transporter. Let me tell you that right now. Okay, we are not mature as a culture for a transporter. that we would be sending each other shit
like fart
all day
bombs,
long. Yeah,
like one of those like fart sense thing. And you're like, oh my god.
fart bombs. We're sending each other fart bombs. I thought about doing a Star Trek episode where it had us, you know what I mean, in our little spacesuits, and then we were farting and they would move, you know what I mean, and see who wins the race. I think that'd be freaking hilarious.
Yeah.
Honestly, you'd just be glad that replicators don't exist. Because you think the girls are bad now with like OnlyFans and stuff. Wait until they find out they could make copies of themselves and sell that. You
Oh
know?
my god.
Yeah. Yeah.
Off you go.
Oh, it's just a cash flow for just having AI pretend like it's you. You know what I mean? They could.
Oh.
They could just have a men. They say men have it hard, but like, trust me, they got it so much easier.
Well, yeah, guys take pictures of their parts and send them to women. I mean, what happens if you have something like that? You know what I mean? They have a replicator so they can make the same part. They're like, I got you. You know what I mean?
And it vibrates. I mean, it's just the cream of the crop.
Right. And I made it smaller so I could lie to people about you. You know?
You imagine a real dude like can vibrate like that?
Oh my
Was
god!
that Casanova? Was he?
Well, all the AI guys that they're going to make are going to be able to do that. They're going to have sex robots. They think the females are, bad that we have female robots. They're going to have male robots that does everything.
Wait a second. Did you say they're going to have?
They have already?
I'm pretty sure they do and have. I'm like, I think that's the thing, bro. I mean, I ain't got money for that sort of thing, nor do I need it, but like, goddamn.
I think it's big in Japan.
But, yeah, they're lonely over there, man. That seems like worst case scenario. Like, that's good. Hang them right in the closet.
Oh my god.
You do that with your real girlfriend, you get a lot of trouble.
Raunchy.
Oh my god, I get one that looks like me so my wife can yell at it all day and then I can walk in like nothing happened.
It just stands there and takes it. I was like, yeah.
Yeah.
I am a fuck.
It repeats the same words over and over again, which doesn't matter because when they start yelling, they don't even listen to you. So it doesn't really have to say much, just grunt every once in a while.
Yep, that's about it. That seems about right. It seems like it saved the whole lot of problem.
Folks, let's look forward to, instead of having to blow up a doll, we got all this cool shit coming.
All right, here we are worried about the future. The future's going to take good care of us.
No more
I'm telling you, we're not mature enough for transporters or replicators yet. We got to get over our immaturities.
What if, like, the reason we don't advance is because we all go into virtual reality and like get stuck in that type of thing?
Wait, so if I step into a transporter, do I come out the other side a woman?
Well, I don't think they call that a transporter.
They call that's possession.
What would you call that then? If not a transporter.
You came out of. Oh, I thought you meant came out of a woman. I'm sorry. So you went.
That's a whole different story. No.
That's actually funny though. Imagine there's gotta be, there's gotta be a set of field goal on the other side to shoot you out. Like, is that what you're thinking? Because that's not what I was thinking. It's good. A doctor with a mitt, but you're a full-blown ass man. You know.
Oh my god, dude, that'd be messed up. A transgender reporter.
That's what I was saying though. I was like, if I go through the transporter, do I come out a woman on the other side? That's what I said.
I think that's like you coming out of a woman.
Oh my god.
Oh,
that's the payback and some programming skills there. Oh,
well, thank God we did away with political correctness a couple of years ago.
wow.
What are you thinking about stuff going on in California? Well, I don't want to talk politics. I'm sorry.
See, California's a mess. It always has been, bro. Nothing's gonna change that. Okay, you just kind of got to go with the flow while you're here.
Yeah.
No matter how you feel about anything, just go with the flow. You'll be so much happier. Like, there's things I see every day that you probably would never see in your town, but they're normal everyday occurrences here.
Wow. Yeah, I used to love California, man.
I'll tell you what, New York is not the best, except that's only the city that's not the best. See, like, and I know California is kind of like that too. I think California might actually be too far gone though. Like, I think New York actually stands a chance of, like, you know, just getting so fed up that it's like, you know what, flip. But yeah, I don't know if Cali's going to go that way.
Well, I don't know, man, because every time I look at it, it's like, who's the lead horse in the race? Is it California or New York? Because both of them are equally screwed.
Oh, and, yeah, they're terrible in their own individual ways. I couldn't agree with you more.
Yeah, they're both one up each other like every month or something. They always come up with something stupid.
A bunch of shitbag communists.
Do you think they should divide California in half, like they said before?
Yes.
Yeah.
Yes.
We say the same thing about New York too.
Get rid of the whole northern half of California. Absolutely.
It makes sense.
Absolutely. They could take LA with it. They just carve it out. Dude, it's like taking out an infestation. You need to get rid of it sometimes.
Yeah.
So, yeah, I'm all there for that.
Yeah. That would make sense, though, honestly. So you think the southern part's better?
Oh, yeah. Well, number one, the weather's better.
Yeah.
So it's always hot.
The north has all the forest fires, though, you know?
Yeah. It's I want to say it's more laid back down here in the southern part. You know what I mean? People go to the beach, they hang out, you know what I mean? Stuff like that. The northern part, they're stuck up. They're, you know what I mean? Bunch of Richies. And it's not very fun.
Gotcha.
And you got to be politically correct everywhere you go. You can't just be cool. You know, like California's known for like dude and, you know what I mean? What's up, man?
Yeah.
Like that, but not in Northern California.
Yeah.
They have sticks up their butts, man. They're not like Southern California because down here we just cruise, go to the beach, man, hang out. You know what I mean? Get your barbecue, you know, at the beach. Northern California, there's Karens everywhere. You know, police alerts and unless you look like you're, you know, shooting up or something, then they leave you alone. You know what I mean? The Karens don't talk to you then.
California.
They literally have a map of where they took shit in San Francisco where you can visit them. You can visit the spots where all human feces are in there.
Oh yeah?
Yeah.
Wow. Are they like designated historical zones or like what's going on?
It seems like that way because you go over there, you spend your $100 for your grape and your toothpick, and once you do that, you get a free show. You know what I mean? Who's out there whizzing on the sidewalk or who's dropping a deuce right in front of you? That's your show for the evening.
Yeah. That's a rad shirt, Jarvis. I like that. Oh, we got muted.
Thank you.
Oh, there we go. Yeah, man. Got the green with the black and the spiral. That's what's up.
That's like an army tie-dye, isn't it?
Yeah. It's like an earthy one. I like it.
Nice.
Tie-dye is really actually a cool tradition, how they really do it, how it started and everything. dyes, and it's all really interesting subjects. They said that Solomon's carpet that could fly was because of the technique they used to make the ink on it. Yeah, it's really cool.
So they were doping the fabric with different patterns of pigmentation that had effect, huh?
And it mattered how you made the ink is what's I'm trying to say, you know?
I mean, if it was Solomon's carpet that flew, I mean, it had nothing to do with his like book of sigils and spells or nothing. Just like
yeah, they actually like the Library of Alexandria. You could stand on the carpet and bring you up to the higher level to like check out a book.
Oh, hold on. Let's get serious for a second. Do you think under the Spink that there's a library? Because they keep showing little pillars under there.
I mean, I think Casey, I think he's kind of legit. Like he's been the most legit. I know we have, you know, other prophets and stuff, but Casey really seems like he's legit, and he said so. So, yeah, I do.
So was that a yes or a no on the library? Yes.
Hey, I'll tell you what might make a fun episode one day.
What's that?
Maybe I could like sit there and try diligently to remote view these places for you.
Oh, there we go.
Ooh, I wonder. I bet they have, but I wonder why they wouldn't. You know, that's dope. That's why your Joe Fuchsia's dope.
Hey, I claim no guaranteed success, but I'm willing to try.
Okay. Yeah, could you imagine? Oh, I think knowledge is more important than all the gold in the world. Like a library, if there's an actual library, like the Library of Alexandria kind of thing, where true knowledge is taught to you. I mean, how do you compete with just a piece of gold? You know?
Yeah,
that would be priceless.
I just want to get to the comment real quick. 8 Center says, by the way, guys, around the word around Egypt is Hawass is getting kicked out, and he really doesn't like his replacement. Gotcha. Ari Hawass, is that his name?
Well, get him out. I want him.
Blocks everybody from seeing everything.
Yeah, he gets on my nerves.
Mm-hmm.
He probably doesn't like him because like it's gonna be a new shift, and he's probably gonna be more open about people. You know, like it. I hate when they want it just a little bitty specimen and they're like, no. It's like, really? I could just like bump into the wall and accidentally like chip something off bigger than that, and you're saying no? You know, like literally. I could actually.
The problem is it's all that they have for now and forever. I think that's how they view it.
Yeah.
And I think that the mystery of it and the allure of it, that's like what keeps their economy of that tourism going, which is a massive part of their economy.
Yeah.
So, like, if you start letting all the exploration happen, you start closing parts of it down, can't have people in, then all of a sudden now you find, like, you know, all these new things out. It becomes common knowledge. The allure is gone. And then what do they have? They literally have no other economic anything going.
Yeah. So, that would say that the allure is gone now because they already showed everything that they supposedly have, right? But the allure is still there. People go there because there's a giant pyramid and they can't understand it. Okay. That's why they go. So if you gave me more, I would want to go more. I would actually pay to go down there to see it at that point when they show the real stuff. You know what I mean?
You know,
that'd be like road trip for all of us when we all finally get paid one time. You know what I mean? Road trip it out to Egypt.
Oh, definitely. That'd be awesome.
Yeah, right. Because the only thing that sets it apart, I mean, other than the fact that it's wildly grand, I mean, it's very grand, you know, but what sets it apart from any of the other, you know, major archaeological finds across the entire globe, you know, is the idea that there's this, it's just simply shrouded in mystery. Yeah, that's what people go for.
It's also possible that it is rightfully shrouded from mystery. They might be hiding something. You know what I mean?
Let me say it this way. People go to the Grand Canyon and it's a hole in the ground. Okay. I mean, let's be honest with each other. It's just something magnificent to see. That's it.
Yeah.
Okay. That's about it. They go over to Yellowstone to see, Old Faithful.
Yep.
They go to see the big trees. I mean, there's no giant mystery about it. It's just awesome to look at.
Well, actually, I mean, I think that the Grand Canyon is kind of a giant mystery because honestly, I don't think that the Colorado River, that's like this little pencil-ass river, carved it like it did. I think that the way that it looks to me is like very akin to like a Lichtenberg strike. It looks like an electrical strike to me all day, and that makes a lot more sense.
Maybe a solar flare.
Some kind of plasmatic discharge event. That's what I believe, personally.
Nice. That's a good thought. Like, what if it doesn't take these millions of years to make those structures, like they say from the creek? That's cool. I like that.
Well, I mean, in some regards, of course, you have water features that carve their path, but then what stops any other major river carving that same exact situation everywhere else? Why does it only occur there? And the Colorado River that goes through there, I mean, it's not that it's small, but it's not the most powerful or the most flow of any river. The sediment there isn't more susceptible than other sediment, like, rock formations and stuff. So it doesn't really add up to me. Like it doesn't, but whatever. Why aren't there Grand Canyons everywhere is the point, right?
Yeah, Bernie was asking, have you guys seen his episodes on it? I have. About the Egyptian stuff that's supposed to be in there. You know what I mean? The writing,
I've heard that.
Wall, stuff. Yeah.
Yeah, they don't let you in. They don't let you into the Grand Canyon. Like even if you pay to go on these tours and stuff, it's very keeping to what specific zones and areas you're allowed to go to. You are stopped immediately if you go off that path. And on top of that, the only loophole that there is to even get onto those areas in the canyon are usually because Native Americans actually have the rights to certain places for rituals and things of that nature. So they're allowed to go down there, and because they're Native Americans, they are also able to monetize that, to be able to keep their church or whatever you call it, like their belief system going to fund it, right? But everything else is government owned and you're restricted from. So,
well, it's too ironic that the Smithsonian is more responsible for that than Hawaii from Egypt. You know what I mean? But it's the same thing, but the Smithsonian is what's going on there. They're in charge of the Grand Canyon and the giants that are uprooted and all the Nephilim type of history that's secluded in America is the Smithsonian Institute.
yeah.
But, I mean, why would there be two? We at least know of two, Hawaii and Smithsonian. Like, they're covering something up.
I mean, the Smithsonian is like, I've heard that before, but in classic government fashion, they deny it all. So,
well, of course. So that's Hawaii,
Well, I'll be honest with you, man. A lot of these structures around the world don't make any sense unless the world was covered in water at one time. Then all the flows and everything, some of the rock formations, everything.
Or the Great Flood.
The
Great Flood, it wouldn't necessarily have to be like a water world, but the Great Flood would do some.
I think gravity's holding back a lot of water in the oceans below the oceans that we know of. I think there's
undoubtedly, yeah.
I think there's at some point it capped off and went up just immediately and then got sucked back down with gravity. So there's something going on there.
I think gravity kind of influenced the size of dinosaurs and stuff. Like they were all giant, you know what I mean? So the gravity was different back then. Like now they say involved into birds, which are like tiny compared to us. So was there a gravity shift?
Well, in the book Edit Dorpa that I always talk about, which again, if anybody has not read that book, that is a strong recommendation on a read. Okay. Now, I don't remember the exact mechanism that it described, but there was this one part of the book that to prove that there was so much water underground, okay, and why we actually have water at all on the surface, right? They went over some basic physics concepts, and I forget what the specific one they hit on here was, but the water could actually make it down and up in a cycle without there being a positive or negative pressure force on it, which is super interesting. And it was going to say how like there are actually large voids in the earth that don't have any water on them, but have water above and below them, you know, which doesn't generally make logical sense to us, you know, when it's seemingly all connected. But, you know, it explained it and it made total sense. I'll have to find that and bring that clip up. But, you know, again, if you haven't read that book, you know, that's like a get on it.
Well,
I wish Eighth was here. He'd probably talk about Agartha on that one.
Mr. Mythos.
I think
you ever watch the Mr. Mythos channel?
Not much.
I feel like I've seen a couple of his things. Yeah.
It's like an hour long. He reads, you know what I mean, and explains things and does things like that. So I like to put it on in the background when I'm working because it kind of takes you on a journey, you know what I mean, as you're going through work. And it's not like the Y files, which it's over pretty quick. You know what I mean? Right. It feels like it's like a long time, like an hour and a half or something.
That's
and
cool.
You're like in the whole thing of it, you know what I mean? And he goes into a DARPA or whatever you called it. And then he goes into what the admiral that went over the North or South Pole, whichever it was. He goes into all that bird.
Mr. Mythos, you said?
Mr. Mythos.
Yeah, I've seen his episodes. You're right. They are very in depth and very like long and well put together. Yeah, I've definitely seen that stuff before.
Your other guy, the what was the guy? Library of the Untold.
Oh yeah, that's my buddy. I love that guy, Joey, man.
Man, his episode, man, on the Coral Castle blew my mind, dude.
So cool, right? Yeah, man.
Wow. That's something else, dude. He went way in depth. So yeah, definitely cool, man. That's somebody I kind of have to watch him, you know what I mean? Because of all the different pictures and stuff and he puts in there. Where the other one you could just have play in the background. With him, you got to watch the channel. So
yeah,
pretty cool.
Yeah, he's always spot on. Does his research. He's really well versed in the stuff. And what I like about him is that, you know, he's got that good recall. You know, so he'll talk about one thing and then be talking about something totally different, but see the connection. He'll be able to bring it up and bring it right in. And it's like, oh yeah, there it is.
Yeah,
the guy reads a lot.
Oh yeah.
Yeah, I can't read that much, man.
You guys think there's something on the dark side of the moon?
Yeah, crater. Yeah, crater.
A crater. Wouldn't it make? It's like the perfect spot, like to be hidden, other than under the oceans and stuff, you know, or the poles. It's like they're all hidden, and you know.
I heard there was a big deal with China sending, you know, satellites and stuff to the dark side of the moon to see what was doing there, and there was some kind of controversy surrounding that. But let's just say that the United States was kind of upset about this. We were upset about the situation. I recall that.
Why? You know,
how dare you look at what's there not to be seen?
Yeah. I
think our whole solar system is different than what we think it is.
I think there's natural wormholes. Like if you just are patient and wait for the right time to go where you want to go, there's like natural routes you can travel through the solar system to get there. Off the assistance of wormholes from magnetic fields, electric fields, like, but you gotta wait right until it's like, boom, let's go, and then do all these like slingshot maneuvers and stuff just off of natural. You know, they've been doing that, but once we see it like electromagnetically, it's going to make a huge difference. You know, so the timing of the launch is going to be more efficient.
Well, you know, the cube on Saturn, and based on what we were talking about earlier today about the standing waves and the structuring of different, you know, substances and molecules and things like that. How do you think there is a hexagon on the top of the thing? You know, it all has to do with that. It's all that standing waves, it's all that resonance. That's how it's there. And what's the implication there when you have a five-sided figure that's prominent at the pole, the point of, you know, highest, you know, energy density? Well, that means that it's literally there structuring matter all the time.
Yeah,
I'd love to find out for real, wouldn't you? Man, sign me up for that first space flight that doesn't end up with a big rocket up my ass, and we'd be all right, man. You know what I mean? Get me something
on.
stable. You know what I mean? Some kind of a flight, and let's go.
Dude,
I'd be breezed in the face on Mars, dude. I'd have to see that, see if those are really pyramids there. You know what I mean? Things like that. You know what I mean? And then see, because it doesn't look the same. It's not freaking red. It's just not. They're fixing the pictures to make it look red. It's not.
Like, not for anything though, Nathan. Like, we're worried about. We need to see if there's pyramids on Mars. First of all, if you do that, like, you know, Elon Musk could be pissed. Second of all, you know, like, aside from that, we have pyramids on our own damn planet or things that look like them that you're not allowed anywhere near and not allowed to sit there and look at.
Yeah,
like
China literally like put dirt and grass over one, you know.
I mean, there's that one mountain in Antarctica that looks like a damn well pyramid to me, jutting right out of the ground, and they were like, "Nah, that's a mountain." Okay, you know, right?
Do you think they'd be mad if I went over and teabagged the Mars rover?
Yes, yes. I think they'd be furious. They would have to. They'd have to ask Congress for a couple $2 billion to send a fucking a bottle of Windex to Mars to clean your ball smudge off the damn thing. You know, like. And then you want to talk about Elon Musk losing his marbles again? There he'd be. He'd be like, "What?
I'll show him
How many billion for Windex?"
Oh my god. It's like when they're debating
the moon on Mars.
Like,
that's what I'll show them.
With the pen, they invested like thousands of dollars to figure out how to use a pen in space, and Russia just used a pencil.
Yeah, and you said thousands, except I think it was millions, and that was then.
It was
I think it was millions, and I think it was then, like, it was a long time ago.
Yeah, but I guess if you think about it, on a contract, you know, I guess a pencil could be erased. You know, so they're investing millions of dollars to use a pen in space, but at least Russia's like, we just use a pencil. You stupid Americans.
Yeah, or they never realized the wicking force of a felt marker, huh? Just saying,
that's
whatever.
A good point. That's a good point. Oh my goodness. That would have been
DARPA. You know what I mean?
Wick it up. Would it wick in zero gravity, you think? I think it would.
Of course, because it's in its the nature of wicking in itself is that it's already in the material. Mm-hmm. So it's traveling through the lattice in which it's confined to get to the point of less dispersion. It has nothing to do with whether it's being pulled down or not. It's going there because it's less diffuse as you use it, so it evens it out in the state of equilibrium.
It's like $1 million problem, and he's like, just wick it with a fucking sponge. You can even just suck it up, like press and like suck it up, and it would just come up, and you just use the pen. Then
you know, I try to be as modest as I can be with whatever, but like you guys break my chops about the fact that, like, because I don't build things, and it's like, well, the engineering aspect, it's like, yeah, I try not to talk about it because you guys are doing it, but like the thing is, I know how to do things too. You know, that's what it boils down to.
I don't doubt it.
Yeah, Josh will tell you about his couch he fixed.
I think a lot of people.
You remember that, huh? I broke my couch. I broke my couch, and I couldn't replace it, and it was very broken because I did things hastily. So I looked around and I had paint stirrers. So I screwed a couple of paint stirrers over the break, and I was like, it should go.
Love it.
Been almost a year.
That's awesome, dude.
Yeah. I guess.
Like,
who knew they were that strong, huh?
Yeah. Well, they do seem like they got to be pretty strong.
Well, I mean, the whole idea is if you flex it this way, well, then it's going to break. But you ever try to break one of those against the grain, we'll have fun with that. So, I mean, that's where all the force is going. So, you know.
Nice.
I use more than one, so it's a little spread out, and then there you go.
Oh, like the multiple sticks concept. Put them all together, and you can't hardly break them, right?
Mm-hmm.
There you go. And you could
Or
hardly break one. If you could break one this way, like it's going to give you a struggle.
Or the egg, you can easily break it on its side, but like when it's tilted up and down, it's very difficult to break.
Mm-hmm. Yeah. I use my brains every so often.
Yeah, I'm all for it. Joe, engineer some more stuff, man. Make it cool.
Yeah. I'll figure it out. I'll have to go dumpster diving or something.
You just get something and blow it up, set it on fire, man. Get some electrical stuff going on.
Listen, I love that idea, but like, I legitimately can't.
Well, I was gonna say, I think a lot of us have ideas that they to do, but like to get the material is the issue.
Oh, hold on. I got something to show you, Joe. I'm gonna show them your eggs.
Oh yeah.
Yeah, that was pretty cool, man.
Well, and this is actually basic proof of concept here about self-structuring in a confined area and how the confined area makes a very big difference as to the ratio. Okay. So you could see right there how the egg structure, regardless of where I put the eggs in, they slid into their own place based on how they space out and based on the area that's available. Right. So now if this plate was too big, well, then it would take more eggs, but they would still fall into the same structure eventually once that ratio is met. If you continue to put eggs in this, they will continue to structure the same way. You'd get one in the middle. Because it's only 5 around the outside, you might actually get a 6th around the perimeter because 6 around would create a sphere. But
so long as it doesn't overflow over the bowl lid, Yeah, I bet you can get 6 though.
Well, right, but I mean that's the confinement at the end of the day is the point, right?
Yeah.
So, I mean, you could definitely crack more eggs in that bowl. There was plenty of room, right? So, but I've done it before. That's how I know it goes. But if if it's only at that ratio that a certain structure is going to form. So if you look at the surface area in this case of what one egg takes up, right, it's going to take that certain amount of eggs to be able to structure in the stable pattern. And then that ratio would be dependent on what pattern you get. And in this case, it was 5.
You got the eggs like perfectly structured around the guy behind it, though.
Yeah. Well, they did that. I didn't. And that's clearly not pasta. So I think that was incoherent.
I love it, man.
Yeah. One could say that eggs are in pasta, so it is coherent.
Yeah, I guess. She's got egg balls. It's a ratio. Oh, I love it. I love the chat, man. They always got something good. Oh, let's see. Egg whites. Let's see. Egg whites field. The gel is the chicken and the nano plate. Nice. Oh, jiggly gel.
We've been on almost 3 hours. Well, you've been on.
Well, dude, we've just been talking BS for the last hour and a half.
Yeah.
Hey, somehow everything we said connected and made sense.
Yeah, it all comes back to the same thing.
Yeah.
So funny, man. Love it.
I wish I knew it like Graphene knew it though, because I really think he did it. And the question is, if you really think he did it,
Who now?
Graphene.
Oh, yeah, that little thing you stand on.
Yeah.
Well, I think he might have, to be honest. I mean, I think that when he was structuring the beetle elytra in the first place, he was able to figure out exactly, not only, it was a bunch of different things that he figured out. Yeah. He figured out the initial properties, but then he realized how they needed to face and how they needed to be structured in order for it to maximize the effect. And that's what he figured out. Yeah. And then he just repeated that over and over again, and then exaggerated it by use of hexagonal honeycomb structure to actually bring a second dimensional layer to the cavern, material effect that was going on. So really getting actually an inverse, so you have one resonance going one way, you have all these things going, and then whatever's above it, it's actually getting caught and then refracted, caught up, and then going opposite, so it would invert. That's what I think. That's what I think was happening.
The cool thing about his book is he gave some exercises you could try, and everybody knows light as a feather, something as stiff as a board, where you put your fingers under somebody and you say light as a feather, stiff as a board, light as a feather, stiff as a board, light as a feather, stiff as a board. He gave that example. He gave an example where everybody goes cross arms. And the weird thing about this is it was 4 people that would go cross arms, and it would build a field that's sustained in that area. Like
Nathan showed me something like that one time. You remember that?
So it gives me confidence that he knew what he was saying, because he's like trying to let us understand in a way, you know what I mean? Like, why would he include these examples throughout his book?
Yeah.
He designed like this. You can take a match head and light the end with the carbon and put it in a jar, and you can use your hands to spin it. It's like he knows what's up.
No, yeah, he definitely does. And he was intuitive also. This was all based on his observations. Like I said, the cross arm thing, Nathan did show me an example of that one time. And these 3 girls were sitting on the floor doing it, and it was remarkable.
Yeah.
That was definitely some hot geometry.
That was some hot geometry, is right. They were all sorts of crisscross applesauce, to each other.
I think it's he was trying to say, like the chitin, I think he was trying to say, if you slightly twist the hexagon structure, right? You got 2 exactly on top of each other, but you slightly twist it as you go up. I think that's what he was trying to say there. I think that's the secret. But
I mean, first of all, twisting chitin sounds like a metamaterial in itself to me. I mean, that's probably as strong as the spider silk, for crying out loud.
Yeah, I mean, they use it for surgeries. Whenever you get a surgery, they'll sew it up with chitin.
Yeah, I didn't realize that. That's cool.
Yep, chitin is really cool, and I like that mushrooms make chitin.
Yep.
That'd be a wild ride, getting on one of the machines with some mushrooms.
Yeah.
I'm
good.
in trouble.
You guys have fun. Yeah.
I'm good. I'm screwed up enough as it is. I could literally close my eyes and hallucinate if I want to on command, so it's fine.
All right, guys, it is getting late. I just I want to show a video real quick from Darren. Excuse me.
Rock on. Let's go.
I'm sorry, it wasn't from Darren. It was from Dennis.
Oh, Dennis, nice.
Yes. Sorry. Ooh, he's got a nice blue light. Look at that. He's got a regular bulb. Oh, I'll put it on now.
He's touching the glass and getting light, and then it's plasma inside the bulb. Is the bulb? It looks like there's a wire in the bottom. No, camera's shifting. I can't tell if
it's just a normal bulb.
It's not connected. Yeah, it is. Okay, that's cool though. I mean, it's conduction through glass, so
that's cool. Neat. I dig that. That's cool.
Yeah.
Well, look at the color by his thumb.
Yeah,
that's cool. It's always different where you're adding yourself in. It's always different.
Yeah,
that's pretty cool, man.
That is cool. I dig that.
I like the color.
Yeah. Nice. He's getting it without touching it too, though. The bluish green, I wonder, is he here? Lighting plasma tube. I wonder what gas that is. Bluish greens. Looks
Neon? No, neon's orange. Argon is blue. Xenon is blue.
That color blue?
I can't tell because my phone has 2%
Oh,
and it's about to die. So if I drop out, that's why. But
yeah, the green does have some stripes in it.
yeah.
Like the
that
bluish
does.
green. I love the bluish
I'll go
green.
plug my phone in.
And it's wavy. You see it waving? Is that argon? Okay.
Argon.
It is argon, yeah.
Good call.
Yeah.
Yep.
Yeah, that was another thing Sheila was showing the other day. Was some of the native colors that the noble gases light up and stuff.
Mhm.
And as we know, they could change depending on what energy is being put in, right?
Mm-hmm. Yeah.
Yeah. Huh. Man, we got a lot more to learn on that subject right there with the light. You know what I mean?
Mm-hmm.
I don't even think I dive into it on my channel, how light works and stuff like that. We're just talking about it on air sometimes.
Well, wouldn't it make sense if you excite the gas and it makes a bluish green color like that? Maybe shine some bluish green color at it and see what it does. Is it the absorption or is it the emission? You know, if the emission has any involvement with the absorption, maybe it can absorb something and we can figure out that, you know, because it's all absorption and emission. In that case, you're emitting.
Okay, hold on. Let's take that another step. If you're able to add a lens to the tube itself, where you could get it to actually focus to a focal point out the lens, and then you're to run that focal point through like a prism of some sort to refract the wavelengths, then you could actually see the full spectrum of what's comprised within that particular potential. Then you could run that same test depending on different energy types. If you have a observation of different colors to see how the entire spectrum has changed. The most interesting outcome that you could probably get out of it is if you find that you make coherent light emission, because at the end of the day, that's the same as a laser. So actually focusing it in that regard would probably, if you were then to reflect and reflect it and then focus it, then you would in fact have a laser with a specific focal point. So, I don't know, something to think about.
I'll be honest with you, man, that the bulb Sheila showed with all the different gases in it, I'd love to get my hands on one of those. That thing, man, I could light that up 10 ways from Sunday. You know what I mean? Let's see all those gases in there, start to put together. How much heat can I put to it? You know what I mean? How much energy? What does it start to do to each other? Yeah, that'd be awesome.
Oh, yeah. I
just
just want to see what it does in general.
I think basically all you have to do though is do something like this. Like whenever you do spectroscopy, it'll show you like the lines that come in there, and it's either going to be an absorption or an emission line. You know what I mean? And then I think these lines indicate what you should shine at it to get it excited externally, instead of like, what he was doing is really cool. It's exciting it and it's giving off these things, but what's the relationship between those lines and what you should add to it?
So check this out. Forget light for a second, and go back to spectroscopy, right? If you take if you get a measure on a spectrogram, right, as to what's being reflected, right, and then you make it inverse as to what's being absorbed, and then you plot out all of those different wave, those specific wave gaps, and wavelengths, and then you make it analogous. You know what exact resonances are going in that are constituent to a given material, because by virtue of its identification, by making it inverse to what it's absorbing, know that that's what it's actually made and therefore comprised of, right?
Shining something at it, like you say, would be the opposite on the wheel. Like you do have those contrasts. The contrast color, I think, is what you're saying. It would be the contrast of the line because it's an absorption. So if you were to emit a light at it and it's absorbing it, You know what I mean? It's telling you this is my absorption color and the contrast.
Exactly.
Yeah.
That's exactly where I'm going with it, right? Because things that are like to combine, right? That's the general rule. So, yeah, that might give a lot of insight into what types of frequencies might actually need to be present in order to structure things at the microscopic scale to actually be able to produce a specific outcome.
Yeah. You're going to need
And
some.
it would be a cocktail, and it's probably more than a couple.
Mm-hmm. But that's how I would attack it, you know, with light or microwaves. All through from microwave, infrared, if you will, all the way up. Like maybe just take the material, get the spectrograph of it. Now we know that's what it's absorbing. So what's the contrast? That would be such a cool experiment. Because it's literally like telling you on the...
Real quick, I got some things to show you here. Some videos of Tesla coils, replications, man, of what we're doing. You remember I did the hot versus cold in the water?
Mm.
This is out of his Tesla coil. See the color breakout?
Oh, yeah.
You're getting some phonons.
It's a trip how it messes with the water there.
But it's that exact reaction, by the way, that you want when inducing the oscillation into water. Because it's both at an energy scale, but also an oscillatory scale at that point. You know, yeah, that's something that's good. All right.
Nice.
I love when users send this stuff. It's cool that everybody's like trying to get their hands on it, you know.
That bulb's got a neat color, man. And it's got neons everywhere too.
Oh yeah.
Oh, the fluorescent. Oh, it stayed lit.
Look, they have no primary on them.
It's all good. He's like, hey, I got the energy now.
Okay, hold on.
That spark.
They have no primary on them. They're just receiving coils. You
Yep.
realize that, right?
I gotta let my dog.
Yep.
That's a lot of energy, man.
Hey, I really invite people to replicate what I've already done and shown. Okay, where you bring the outer field out of the center and then you inverse it, you know, and then you add a scalar component, because like you'll get those kinds of distances and stuff without you know, without even having any other coil. Like you'll get that distance.
Oh, there you go. Look at that.
Well, that's rad. I dig that. Is that incandescent? I don't think so.
No, it's just regular light bulb.
Yeah,
It is.
Well, it does look like an incandescent, actually.
It does, but I would have expected it to kind of light up a little bit.
It's kind of hard to tell. It's usually a LED if it's not, but that looks like it's incandescent.
Well, you could see the thing in the center.
Now, what's interesting is I've had this same effect with an LED bulb before, where you're touching it, it'll actually, you know, have a plasma discharge on the inside of the bulb, even if the bulb's not lit up. In fact, it only really happens at lower power levels, because other than that, it'll light the bulb.
Okay, so check it out. Yeah, it's got a filament in it. I have the same light bulb. He has this thing, like the wire on his desk that comes right off the number 2 coil. And it burns that hole right through the wood.
He's doing the figures in his wood. Off a light bulb.
Dude,
that's
some
pretty
trippy
cool
stuff, huh?
What are they called? The figures? The lists?
Oh, there he goes.
The like where you have an arc in wood and it makes fractal patterns.
Yeah, that's what I was saying. The Lichtenberg.
Lichtenberg, thank you. I can't.
Yeah, that's what I think the Grand Canyon is. That's what I was saying.
Yeah. But he did it in the wood. You see it out the
yeah. Mm-hmm.
Neon. I love neon. It's one of the funnest things to work with. Don
Yeah,
Smith
he's got neons
all the time to know how it's told. You can really, it makes it easy using neons and Proven. It's really all you got to do to see where it's tuned. Like they used to do, we'll talk about this later.
So hold on, I'll show you my 2 regular light bulbs real quick.
Yeah. Well, Nathan's been saying that same sort of thing about Alexei's experiment for a long time, that he had the neon bulbs
And get
out
another
in the distance,
Think of it
Or-
as a tool.
or the LED bulbs.
Look at that.
It'll tell you where the resonance is, you know.
Oh, it's just going
Yeah.
crazy on the bottom.
Yeah, that is crazy. Look at that. That's rad.
Yeah. Ah, so cool. I love that people are like excited about this because it's a good time coming. I think people got to stop worrying about the worst thing that can happen. We can just think happy thoughts and fly like Peter Pan.
Yeah, that looks like magic jellyfish, and that's cool.
Just kidding. Yeah.
Okay, hold on. I got another one for you. This is a half power. Yeah, this is. I had that one on the bottom, but then I took an LED light.
Oh, cool.
Yeah, that thing has about 3 seconds before it fails.
That thing is dude, it was so bright. I'm only at half power on that coil too.
Hey, would you ever do the fester thing? Just stick a light bulb in your mouth?
Oh, I don't even know about that. You burn
No,
them
that'd
out.
be nuts though. I think I may have seen that, but that's when you know it's cold electricity if you can pull off a fester.
They had some college guy on. I won't say that. The people messing with people with light bulbs.
There seems to be like a fairly new guy on the scene. I don't know. I think Brandon thinks he's Canadian. I'm not really sure, but I've watched a few of his videos and stuff, but he's really trying to crack the whole free energy thing, you know?
No,
But he's
Brandon's
just doing stuff that we've kind of already kind of done or talked about. But,
Brandon,
you know.
yeah, Brandon's cool, man.
No, I'm not talking about Brandon, though. I'm talking about this guy that Brandon sent me a video. I was like, oh, I saw this guy. I forget his name.
Gotcha.
It's like free energy for everybody, but his following's getting big fast.
Yeah, but I was gonna remark on that, but I'm just so tired right now.
I'm just saying, like, you know what he did was he just reformatted plasma channel into free energy channel, basically.
Well,
And
he's
he
not
follows
doing
that same exact format.
anything different. He's just
No, that's what I'm
stuff.
aware.
It's over and
I know
over the same thing, but he's good at marketing, is all I'm gonna say.
Of course.
It's nothing new. He's
I
just
know.
doing yeah.
I was just exposing to the fact that
Yeah.
you know, we talked about these things, and
Right.
all of a sudden he started showing up in my feed, and I've never seen him before, and the guy's rapidly growing, so it's like, oh, okay, well, here he is.
Yeah.
That's what happened to American Alchemist too. You know, he started and then boom. You know?
Yeah, no, that guy's great though.
Yeah.
Is that Jesse Michaels that's an American Alchemist, or is that someone else?
That's
I know who you're talking about, but
yeah. Ben used to talk about that a lot, like how like you could just go and because the topic is hot. It's just to be honest, if I see a 3-hour video, I'm like skip. If it's like a 10-minute video, I'm like, all right. You know what I mean? Because if I want to know something, I go to AI. If I want to be entertained, or like if I feel like something gets to the point, then 10-minute video is okay. I don't think most people want to go above 10 minutes, just to be honest. Like,
are you saying that 3 hours and 20 minutes is a little much?
But that's okay. You can dice it up into a 10-minute video. The best things that happen, just
well.
Yeah.
All right, guys. Real quick before we get out of here, I just want to show this one more time. Give a shout out to Sean here.
Yeah. It looks like a toy. I want to play with it.
Like one of those bioluminescent jellyfish.
Yeah, it's an awesome thing, man. Like I said, if you remember the channel, man, check it up. Check out the member section over there, and you'll see this on the short videos, man. It's like mesmerizing. if I had this on my wall, I'd be like looking at it all night. You know what I mean?
I
Yeah.
feel like they sell things like that at Spencer's, like gifts, you know. But
Yeah,
but I don't know that it's doing the same thing, but it looks the same.
yeah, it does remind me of a Spencer's thing you would see.
You know what I'm saying? Yeah.
Yeah. I need to go back to Spencer's. I wonder what they have. Like when I was young, they used to have such cool stuff like that.
Yeah. Well, I don't know if they still sell that or if they're just into, you know, plastic, you know, vibrating devices and such.
That's what I figured.
But then again, you know, like I mean, that could be relevant for the experimentation. You know,
I guess.
you know, just put that in a glass of water, let it buzz
Yeah,
around.
we'll
see
let
what
you
goes.
do that one. Yeah.
Go ahead. Go ahead, Joe. You got
Yeah,
it.
Joe goes to show his crystal videos and it's all vibrating.
He's like, I told you. It like really works. So we're like, God dang, he was right.
Right. You just shove the dildo in the glass of water and hope for the best.
It's like
It's basically what we're doing anyway. What's the difference? You just hope that it's some kind of fraction of the vibration that you need, and then you hope for the best. That's it.
Well, I think he just
He used fractal geometry and vibration in the vortex.
Hey, look, some of them even have pulse mode. So, like, you know, like you can just make it go boom, 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 and then you know, and like then you get a structure that is like, you know, alternating.
burst it out.
Alternating crystal structure.
I think I got it quick.
Oh man. Oh, it's like old school. You say your mom's so old she used to have the theme version.
Yeah, plug that thing into the fucking wall.
Lordy B, you guys get raunchy, man.
Oh, all right, guys. It's definitely time to take off because we're getting losing it here now. All right, guys. I want to thank everybody in the chat. You guys have been great, Jarvis and Joe. Thank you guys for coming on, man. It's been an awesome show.
Peace and love.
Thanks, guys.
Later.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.